If the ancient world has taught us anything, it is that certainty rarely lasts. Again and again, discoveries have overturned ideas that once seemed unquestionable. A forgotten city changes the map of a civilization. A newly translated inscription rewrites a historical timeline. A hidden chamber reveals that a monument was never fully understood in the first place. What makes ancient mysteries so compelling is not that they defy science, but that they constantly force science to ask new questions. Every ruin is a surviving piece of evidence from a world that no longer exists, and sometimes that evidence refuses to fit neatly into the story we expected. The result is a past that feels less like a finished record and more like an investigation still in progress. The volcanic plateau of Rujum El Hiri hides one of the oldest and strangest megalithic structures on Earth. Thousands of black basalt stones form enormous concentric rings older than many pyramids, larger than some Bronze Age settlements, and almost invisible from ground level. The site has puzzled archaeologists for decades. No one fully agrees on who built it, how they measured it, or why its massive stone circles appear aligned with the sky itself. Unlike famous ancient monuments that dominated historical records, Rujum El Hiri remained largely unknown for centuries because its true shape cannot easily be recognized from the ground. The structure blends into the dark basalt landscape of the Golan Heights, around 16 kilometers east of the Sea of Galilee. The site was properly identified only after aerial surveys conducted during the 20th century revealed its enormous circular geometry. From above, archaeologists suddenly saw a giant system of concentric stone rings surrounding a central cairn. The entire complex spans roughly 150 meters in diameter and contains an estimated 40,000 tons of basalt rock. Radiocarbon evidence and pottery fragments suggest the outer rings may date to around 3000, 2700 BCE, placing the structure in the early Bronze Age, possibly older than the final construction phases of Stonehenge and close in age to the earliest Egyptian pyramids. But unlike Egypt or Mesopotamia, no major urban civilization existed nearby that could easily explain the planning and labor required for such a massive construction. The greatest mystery surrounding Rujum El Hiri is not simply its size, it is its apparent astronomical precision. Several archaeoastronomers discovered that openings within the stone rings align closely with the sunrise during the summer solstice, while other corridors appear linked to equinox positions and seasonal solar movements. This suggests the builders were tracking the sun with surprising accuracy thousands of years before advanced scientific instruments officially existed in the region. One narrow entrance in particular appears oriented toward the solstice sunrise, as it would have appeared around 3000 BCE. Because Earth's axial tilt slowly changes over millennia through a process called axial precession, these alignments no longer match perfectly today. Ironically, that imperfection became evidence that the structure truly is ancient. To determine solstice points accurately, ancient observers would have needed long-term horizon observations, seasonal tracking over many years, stable geometric reference points, knowledge of angular consistency, and methods for transferring celestial observations into architectural layouts. Even a 1-degree error across a structure nearly 150 meters wide would significantly distort the geometry, yet many sections remain surprisingly coherent despite thousands of years of erosion. Researchers have compared the site to other ancient observatories such as Nabta Playa and the solar alignments of Chaco Culture National Historical Park. But Rujum El Hiri differs in one critical way. It was constructed using dark volcanic basalt in a remote region with no known centralized state power. Some scientists believe the surrounding hills of the Golan Plateau were intentionally incorporated into the astronomical design, effectively turning the natural horizon into part of a giant observational instrument. If true, the builders were thinking not merely as labourers, but as landscape engineers capable of integrating terrain, sunlight, seasonal motion and architecture into a single functioning system. For a society from the early Bronze Age, that level of environmental calculation remains extremely difficult to explain. Basalt is one of the hardest volcanic stones commonly found in the ancient world, significantly heavier and more difficult to shape than limestone. Yet the people of Rujam-el-Hiri moved and arranged approximately 40,000 tons of it into massive concentric circles without evidence of advanced metal tools, wheeled transport systems, or large domesticated draft animals. That creates a major engineering paradox. Archaeologists estimate some stones weigh several hundred kilograms each. Even if smaller groups carry them manually, the logistics would still have required coordinated labour on a scale difficult to explain for scattered pastoral communities of the early Bronze Age. The geometry itself deepens the mystery. Maintaining nearly circular rings across large distances requires some method of centralised measurement. Modern researchers suspect the builders may have used central anchor poles, rope-based radius measurement systems, primitive surveying techniques, and celestial reference markers. The structure contains multiple concentric walls, some over 3 meters thick, arranged in patterns that appear deliberate rather than random. This level of planning resembles later monumental architecture from civilizations far more socially organized. Engineers comparing ancient sites have noted that even slight angular inconsistencies would distort the circles dramatically over such distances, yet many sections maintain consistent curvature despite millennia of collapse and environmental damage. The unavoidable question is how a prehistoric society with limited technology achieved this scale of precision. At the center of Rujam-el-Hiri lies a massive stone cairn often interpreted as a burial chamber, but excavations revealed something deeply strange. Evidence suggests the cairn may have been added centuries after the outer rings were already constructed. This discovery completely changed how archaeologists interpret the monument. If the burial structure came later, then the original purpose of the site may have had nothing to do with funerary rituals at all. Some researchers now believe the outer rings originally functioned as a ceremonial gathering complex, a seasonal calendar system, an astronomical observatory, a ritual landscape connected to celestial events, or even a territorial marker visible from elevated terrain. The interior pathways are awkward and maze-like, making them impractical for ordinary habitation or military defense. Instead, the layout feels symbolic and highly controlled, almost theatrical in its movement. The site may have been designed for ritual processions or ceremonies linked directly to seasonal observations of the sky. That possibility raises another unsettling idea. The people who built Rujam-el-Hiri may have organized entire social rituals around celestial cycles and the movement of the sun itself. Rujam-el-Hiri sits within a volcanic basalt field formed by ancient eruptions across the Golan Heights. Some geological surveys have reported localized magnetic irregularities in the surrounding terrain, though the evidence remains debated. Still, the connection between megalithic structures and unusual geology appears repeatedly across the ancient world. Sites such as Stonehenge and Karnak stones are also associated with distinctive geological environments. Ancient cultures often treated volcanically active zones, fault lines, springs, and unusual rock formations as sacred places. Modern archaeologists increasingly suspect prehistoric builders selected locations not randomly, but because they perceived subtle environmental properties tied to spirituality or cosmology. At Rujam-el-Hiri, the black basalt landscape creates an almost unnatural visual effect. Under certain lighting conditions, the rings appear to dissolve into the terrain itself. This may explain why the monument remained hidden for so long, and perhaps why it was intentionally constructed there in the first place. One of the strangest aspects of Rujma El Hiri is that its full geometry only becomes obvious from above. At ground level, visitors mostly see scattered walls of volcanic stone, but aerial imagery reveals a giant circular design stretching across the plateau with remarkable symmetry. This has fueled endless speculation. Of course, there is no scientific evidence that ancient people possessed aerial technology, yet archaeologists still struggle to explain why such enormous geometric effort was invested into a pattern difficult to appreciate from human eye level. Some researchers argue the design may have been intended for symbolic rather than visual purposes, perhaps representing cosmological beliefs, sacred circles, or celestial cycles. Others suggest elevated observation points on nearby hills may once have revealed more of the design than is visible today. Whatever the explanation, Rujma El Hiri belongs to a category of ancient structures whose true form only emerges when viewed at scale. That alone makes it one of the most psychologically unsettling monuments of the prehistoric world. Do you think Rujma El Hiri was truly an ancient observatory, or evidence of a lost knowledge we still don't fully understand? Share your theory in the comments below. In one of the hottest valleys in the Middle East, near the Jordan Rift Valley, where summer temperatures regularly exceed 40 degrees Celsius, the ruins of Bet Shean National Park hide an ancient megacity filled with theatres, bathhouses, fountains, underground drainage tunnels, and cooling systems so advanced that some archaeologists compare parts of it to a primitive form of urban climate engineering. For more than 5,000 years, civilizations kept rebuilding this city directly on top of earthquake zones, extreme heat, and unstable soil. The question is simple. How did Bet Shean survive for so long when entire ancient cities around it disappeared? Modern excavations began in the early 20th century, but the largest discoveries came after extensive digs led by Israeli archaeologists in the 1980s and 1990s. Beneath layers of clapped stone, researchers uncovered a Roman theatre capable of holding nearly 7,000 people, Byzantine bath complexes, underground sewage systems, long colonnaded streets, and hydraulic infrastructure stretching across the city. What shocked researchers most was the scale. More than 20 archaeological layers were stacked vertically beneath the site, revealing continuous occupation from the Bronze Age through the Islamic era. Each civilization rebuilt directly over the ruins of the previous one, creating what some archaeologists describe as a compressed timeline of urban engineering. The greatest mystery surrounding Bet Shean is not its temples or theatres. It is water. The city existed in an environment where heat, evaporation, and drought should have severely limited urban growth. Yet Bet Shean became one of the largest and wealthiest cities in the Roman Decapolis network. Archaeologists discovered an enormous hydraulic system, feeding the city from springs and channels connected to the Jordan Valley, and the engineering precision is difficult to explain using the technological image most people associate with the ancient world. Some channels maintained gradients so accurate that water could travel kilometers with minimal stagnation or overflow. Even tiny slope errors would have destroyed flow efficiency. Modern civil engineers note that Roman aqueduct systems often operated at gradients as low as 0.15%, requiring astonishing surveying accuracy without laser instruments or modern leveling tools. At Bet Shean, several underground channels still preserve waterproof hydraulic plaster after nearly 2,000 years. Chemical analysis indicates mixtures of lime, ash, crushed ceramics, and volcanic materials similar to Roman pozzolanic concrete, a material famous for surviving marine erosion better than many modern concretes. But the deeper mystery appears inside the city itself. Researchers found evidence that many public structures were intentionally designed to manipulate airflow and temperature naturally. Long stone corridors accelerated wind movement through pressure differences, arched ceilings trapped rising heat above occupied spaces, thick limestone walls slowed thermal transfer, and underground drainage tunnels may have lowered surrounding temperatures through evaporative cooling. In some market districts, temperatures may have remained several degrees cooler than the exposed streets outside. Comparable passive cooling systems existed thousands of kilometers away in Persian desert cities like Yazd, where wind catchers and underground qanat tunnels created natural air conditioning centuries before electricity. Yet Bet Shean presents a different puzzle because these cooling principles were integrated into a massive Roman urban centre, rather than isolated desert compounds. Some historians believe the city may represent one of the earliest examples of climate-adaptive urban planning in the ancient Near East. Others argue that its sophistication emerged from centuries of accumulated engineering knowledge shared between Egyptian, Nabatean, Greek, and Roman builders moving through the trade networks of the Jordan Valley. What makes the mystery even more frustrating is that no surviving written manual fully explains how the hydraulic and cooling systems were designed or maintained. Bet Shean stood directly beside one of the most dangerous fault systems in the Middle East, the Jordan Rift Fault Zone. The city suffered repeated earthquakes over centuries, culminating in the catastrophic earthquake of 749 AD that largely destroyed the urban centre. Yet many surviving structures reveal what appear to be intentional anti-seismic construction techniques. Archaeologists discovered flexible stone layering beneath some foundations, metal clamps joining massive blocks together, lead-filled connectors capable of absorbing movement, and alternating stone sizes that distributed stress more evenly during tremors. Some collapse columns even display fracture patterns, suggesting controlled structural failure instead of complete shattering. These techniques resemble earthquake-resistant principles later observed at sites such as Machu Picchu, Hattusa, and Pompeii. Modern seismic engineers studying Roman construction have suggested that certain ancient builders may have developed empirical understandings of ground vibration through centuries of observation and rebuilding. At Bet Shean, that knowledge may have been essential for survival. Still, the city ultimately failed against the earthquake of 749 AD. Entire streets collapsed simultaneously, and massive columns fell in the same direction, preserving what looks like a frozen moment of destruction. Some researchers compare the site to a Middle Eastern Pompeii, not buried beneath volcanic ash, but shattered by tectonic violence. The Roman theatre of Bet Shean remains one of the most acoustically impressive structures in the region. Even today, voices projected from the stage can travel upward through the seating area with remarkable clarity. Researchers studying Roman theatres discovered that specific geometric ratios naturally amplified vocal frequencies. Curved seating rows reflected sound waves upward, while limestone surfaces reduced distortion and excessive echo. What remains unexplained is how ancient architects repeatedly achieved these acoustic effects across the Roman world without modern mathematical acoustics or electronic modelling systems. At Bet Shean, the theatre's design appears carefully optimized. Seating angles improved sound reflection, stone density minimized echo interference, and stage positioning enhanced vocal projection across thousands of seats. Some historians believe Roman architects relied entirely on empirical experimentation developed over generations. Others argue they possessed advanced geometric formulas now lost to history. Comparable acoustic precision can also be observed at Epidaurus and Aspendos, but Bet Shean is unusual because such sophisticated acoustics existed in a frontier desert city rather than a major imperial capital. The streets of Bet Shean were paved using basalt and limestone slabs thick enough to survive centuries of trade, military traffic, earthquakes, and extreme climate stress. Wheel ruts carved into the stone reveal something extraordinary: traffic standardization. Many ruts share nearly identical spacing, suggesting transport vehicles across the region may have followed standardized axle widths. This implies organized logistics and transportation systems on a scale rarely associated with ancient desert cities. Roman road networks across the empire stretched more than 400,000 kilometers, and Bet Shean functioned as a strategic commercial hub linking Damascus, the Mediterranean coast, and Egypt. Some paving stones at the site remain aligned despite repeated seismic activity, leading researchers to suspect deeper engineering layers beneath the visible road surfaces. In 749 AD, a massive earthquake destroyed Bet Shean within minutes. Excavations revealed crushed bath houses, collapsed streets, and massive columns frozen exactly where they fell. Some shops still contained goods, suggesting many residents had little time to escape. Geological studies indicate soil liquefaction may have caused foundations to fail almost instantly during the quake. What do you think was the greatest mystery of Bet Shean? Let us know in the comments below. Forests and valleys surround Pendle Hill as it rises alone above the landscape like a giant stone marker. For centuries, it was feared because of witch legends. But long before the famous witch trials of 1612, Pendle Hill may already have been one of Britain's strangest ancient sites. A place connected to mysterious alignment systems, prehistoric navigation, astronomical observation, and technologies that still remain unexplained. The hill was formally documented in medieval records, but archaeological interest intensified during the 18th and 19th centuries when researchers began noticing unusual earthworks, ancient pathways, ritual locations, and visual alignments surrounding the mountain. Modern topographic surveys later revealed that Pendle Hill occupies one of the most dominant observation points in the region, visible from enormous distances across northern England. What initially appeared to be only a natural hill slowly became something far more disturbing, a possible centerpiece of a forgotten prehistoric orientation network. Pendle Hill stands approximately 557 meters above sea level, isolated from surrounding terrain in a way that makes it visually overwhelming. Unlike mountains hidden inside ranges, Pendle rises independently, giving it near-total visibility across valleys and ancient travel corridors. This immediately attracted the attention of landscape archaeologists, because many prehistoric societies selected elevated isolated landmarks for ceremonial and navigational purposes. Similar patterns can be seen at Newgrange, where ancient builders aligned structures with winter solstice sunlight, and at Machu Picchu, where mountains functioned as sacred astronomical references. Researchers studying visibility analysis discovered that Pendle Hill can be seen from dozens of kilometers away under clear conditions. Before modern roads, GPS, or even reliable maps, such landmarks may have served as giant orientation beacons for human movement. What makes this even stranger is the geometric prominence of the hill. Using GIS terrain modeling, some modern researchers found that Pendle occupies a naturally optimized line-of-sight position relative to several ancient pathways and ritual landscapes. In other words, its location may have made it one of the most effective natural navigation points in the region thousands of years ago. The greatest mystery surrounding Pendle Hill involves the controversial theory of ley lines. first popularized in the early 20th century by Alfred Watkins, ley lines proposed that ancient monuments, hills, standing stones, burial mounds, and sacred wells were intentionally placed along straight geographical alignments across enormous distances. Mainstream archaeology remained skeptical of many ley line claims. However, Pendle Hill repeatedly appears in alignment studies because multiple ancient sites in Lancashire and Yorkshire seem to connect visually or geographically through the hill itself. Some researchers argue this cannot be coincidence. Ancient societies without compasses somehow crossed forests, mountains, wetlands, and dense fog with remarkable precision. In Britain especially, weather conditions are often catastrophic for long-distance navigation. Thick mist can reduce visibility to only a few meters. Yet prehistoric communities still established trade routes and ceremonial networks over vast territories. One theory suggests that elevated landmarks like Pendle Hill acted as fixed orientation anchors. Instead of using magnetic navigation, ancient travelers may have relied on solar positioning, stellar movement, horizon geometry, and interconnected sightlines between sacred sites. This concept resembles systems used by other ancient civilizations. In the American Southwest, Chaco Culture National Historical Park contains roads stretching across deserts with astonishing directional accuracy. Some roads deviate less than a few degrees over many kilometers despite difficult terrain. Similarly, the Nazca civilization in Peru created massive geoglyph systems visible only from elevated viewpoints, suggesting advanced spatial planning long before aerial technology existed. At Pendle Hill, several researchers noted that ancient pathways and ritual points align unusually well with sunrise and sunset positions during seasonal transitions. If prehistoric Britons used Pendle as a central visual marker, they may have constructed one of the earliest large-scale orientation systems in Northern Europe. The mathematics behind this possibility is disturbing. Even a 1-degree error in directional alignment can create positional deviations of hundreds of meters across long distances. Maintaining such accuracy without modern instruments would require repeated astronomical observation and sophisticated environmental memory. Some experts believe prehistoric observers may have tracked solar azimuth positions using horizon markers. During solstices, the sun rises and sets at predictable extreme points along the horizon. By repeatedly observing these movements over generations, ancient societies could theoretically build directional systems accurate enough for navigation and ceremonial alignment. If true, Pendle Hill was not merely a mountain, it may have been part of a prehistoric geographic operating system. Historical accounts from the 18th and 19th centuries describe circular earthworks, unusual embankments, and possible ritual structures near Pendle Hill. Most no longer exist due to agriculture and erosion, but some faint traces remain detectable through aerial photography and LiDAR scanning. This raises an unsettling possibility. Pendle Hill's summit possesses extraordinary visibility. Fire or reflected light from the peak could potentially be seen across enormous portions of Lancashire. Some historians speculate the hill may once have functioned as a signalling platform centuries before Roman beacon systems appeared in Britain. Comparable systems existed throughout the ancient world. Byzantine warning networks transmitted military signals over hundreds of kilometers using fire towers. In Iron Age Britain, hill fort communication systems may have worked similarly. But Pendle's location makes it uniquely efficient. Because the hill dominates surrounding terrain, even primitive fire signaling would have achieved enormous visual range. Some archaeologists suspect that prehistoric communities may have used sequential hilltop communication long before written history recorded such technology. Pendle Hill's supernatural reputation may have deeper geological origins. The region is dominated by millstone grit formations, coarse sedimentary rock capable of influencing local moisture retention, acoustics, and possibly electromagnetic conditions. Visitors for centuries reported disorientation, abnormal echoes, shifting fog formations, and unusual atmospheric lights. Scientists proposed several possible explanations. Temperature inversions can trap sound and distort spatial perception. Wet mineral-rich rock can affect electrical conductivity in the ground. Sudden atmospheric pressure changes across elevated terrain may also produce low-frequency vibrations capable of creating anxiety or confusion in humans. Similar environmental anomalies have been reported near Rujum El Hiri and Stonehenge, sites long associated with ritual behavior and supernatural legends. This connection appears repeatedly throughout ancient history. Many sacred locations were built in geologically unusual environments. Modern science still debates whether ancient humans intentionally selected such locations because of psychological or sensory effects. If Pendle Hill produced even mild environmental anomalies, prehistoric populations may have interpreted the site as spiritually powerful. Another theory proposes that Pendle Hill functioned as a seasonal astronomical marker. Because of its isolated geometry, the hill creates dramatic solar positions during solstices and equinoxes when viewed from nearby valleys. Ancient observers may have used these horizon events to track seasonal change. Agricultural societies depended on accurate timing. Planting crops too early or too late could mean starvation. Before written calendars, monitoring the movement of the sun across the horizon was one of humanity's oldest scientific systems. At Stonehenge, builders aligned stones with midsummer sunrise. At Newgrange, winter solstice sunlight illuminates an interior chamber with astonishing precision for only a few minutes each year. Pendle Hill may represent a natural version of the same concept. If ancient Britons repeatedly observed solar movement relative to the hill's profile, they could have created a reliable seasonal calendar using nothing more than landscape geometry. That would mean prehistoric communities in northern England possessed far more advanced observational knowledge than historians once believed. Do you think Pendle Hill was only the source of ancient superstition? Or could it have been part of a lost prehistoric knowledge system far more advanced than we realize? Share your thoughts in the comments below. On the edge of ancient Athens, inside Elefsina, thousands of people entered a dark stone hall for nearly 2,000 years and emerged believing they had witnessed the gods themselves. No one fully explained what happened inside, and whatever the priests were doing was so powerful that even Roman emperors crossed the Mediterranean to experience it. The ruins of Elefsina were systematically excavated during the 19th and early 20th centuries by Greek archaeologists, including Dimitrios Philios and later researchers from the Archaeological Society of Athens. Beneath layers of Roman and Byzantine remains, they uncovered the telesterion, one of the strangest ceremonial structures ever built in the ancient world. For centuries, the Eleusinian mysteries were considered the most sacred initiation ritual in Greece. Philosophers such as Plato, Cicero, and Sophocles described the ceremonies with unusual reverence, and Cicero even claimed the rites transformed humanity from a savage existence into civilization itself. Yet almost nobody described the actual ritual. Participants swore absolute secrecy under penalty of death, and unlike Egyptian tomb inscriptions or Mesopotamian ritual tablets, Elefsina left behind almost no direct explanation of what initiates witnessed inside the sanctuary. This absence of information became one of archaeology's greatest mysteries. Tens of thousands of people attended these ceremonies across nearly 2 millennia, but the secret survived longer than entire empires. Modern historians believe the experience was designed to psychologically overwhelm participants through a combination of architecture, darkness, fasting, sound manipulation, ritual movement, and possibly psychoactive chemistry. One theory centers around a sacred drink called kaikion. Ancient texts mention it repeatedly but never explain its composition in detail. In 1978, ethnomycologist R. Gordon Wasson proposed that kikion may have contained ergot fungus, a naturally occurring mold growing on grain that contains alkaloids chemically related to LSD. The theory remains controversial but scientifically plausible. Ergot compounds can alter perception, intensify sound sensitivity, distort time perception, and trigger profound emotional experiences. However, ergot is also extremely dangerous. Incorrect dosage can cause seizures, gangrene, hallucinations, or death, and medieval outbreaks of ergot poisoning killed thousands across Europe. That creates a disturbing possibility. If the priests of Elefsina truly used ergot-based compounds safely for centuries, then they may have possessed an unexpectedly advanced empirical understanding of neurochemistry long before modern science existed. The greatest mystery of Elefsina was not the ritual itself, but the building designed to control human perception. At the center of the sanctuary stood the telesterion, a massive enclosed initiation hall, unlike almost any traditional Greek temple. Most Greek temples emphasized exterior beauty and open-air visibility, but the telesterion did the opposite. It was designed to trap people inside darkness. The structure evolved across centuries and eventually reached approximately 50 meters on each side. Estimates suggest it could hold between 3,000 and 5,000 initiates simultaneously, an enormous number for the ancient world. Stone seating surrounded the interior in stepped formations, focusing attention toward a central sacred chamber called the anaktoron. What shocked modern researchers was the building's acoustic behavior. Unlike theaters designed for clarity across open spaces, the telesterion appears optimized for resonance, echo layering, and directional confusion. Some acoustic engineers studying ancient ritual architecture believe the enclosed stone geometry could amplify low-frequency sounds and create disorienting reverberations. In complete darkness, the human brain struggles to locate sound direction accurately. Low-frequency resonance between roughly 30 and 80 Hz can also trigger physical sensations in the chest, anxiety responses, and altered emotional states. Modern psychoacoustic studies show prolonged exposure to certain frequencies can increase suggestibility and emotional intensity. The telesterion may have exploited exactly those effects. Bronze instruments, chanting, synchronized footsteps, hidden chambers, and reverberating stone surfaces could have produced an experience far beyond ordinary religious ceremonies. Ancient initiates repeatedly described terror, awe, blinding light, and the sensation of crossing into another reality. Some researchers compare the telesterion to other ancient structures associated with altered states of consciousness. The hypogeum of Hal Saflieni hypogeum contains chambers resonating around 110 Hz, a frequency shown in modern studies to affect brain activity and vocal perception. The ceremonial galleries of Chavin de Huantar used underground stone corridors and water acoustics to psychologically overwhelm pilgrims. But Elefsina may have achieved something even more advanced. Its architecture was repeatedly rebuilt after destruction, invasions, and earthquakes, yet the core acoustic geometry remained preserved. That strongly suggests the sound behavior of the building was intentional, rather than accidental. The telesterion was not merely a temple, it may have been one of humanity's earliest engineered psychological environments. Ancient descriptions repeatedly mention sudden flashes of light appearing during the climax of the ritual. In total darkness, even a weak light source becomes neurologically overwhelming, but witnesses implied something far more dramatic occurred inside the telesterion. The Greek word epopteia referred to the final revelation, the moment initiates saw the sacred truth. Nobody knows how the priest created this effect, Some historians suspect polished bronze mirrors may have reflected concentrated firelight through hidden openings, while others believe mineral compounds such as gypsum, calcite, or phosphorescent substances could have amplified luminous effects inside the sealed chamber. Even more intriguing is the role of sensory deprivation. Modern neuroscience shows that extended darkness, fasting, emotional stress, repetitive chanting, and sleep deprivation can significantly alter brain chemistry. Dopamine and serotonin responses become unstable, hallucinations become more likely, and emotional memory becomes intensified. Military interrogation studies, isolation experiments, and sensory deprivation research all demonstrate how rapidly human perception changes under controlled environmental stress. The priests of Elefsina may have discovered those effects experimentally thousands of years ago. The experience began long before initiates entered the Telesterion. Participants travelled roughly 21 kilometres from Athens to Elefsina along the Sacred Way, a ritual road crossing bridges, cemeteries, wells, and symbolic landmarks tied to death and rebirth mythology. The procession lasted for hours. Initiates fasted, endured physical exhaustion, and participated in synchronized chanting before entering the sanctuary. Modern psychologists would recognize this immediately. Physical stress increases emotional receptivity and group conformity. The combination resembles techniques later used in military conditioning, initiation systems, and intense religious experiences worldwide. Researchers comparing ancient rituals across civilizations note striking parallels with Mesoamerican pilgrimage systems, Egyptian temple processions, and even modern crowd psychology experiments. Elefsina appears to have weaponized anticipation itself. By the time initiates finally entered the Dark Hall, their brains may already have been neurologically primed for transcendence. Another mystery lies beneath the visible ruins. Greece is one of the most earthquake-prone regions in Europe. Yet portions of the Telesterion's foundations survived repeated seismic events for centuries. Archaeological surveys show tightly interlocked stone blocks, layered foundation systems, and load distribution methods unusually sophisticated for their time. Some stone joints fit with millimeter-level precision. The sanctuary underwent multiple reconstructions from the Archaic period through Roman rule, but builders consistently preserved the ritual core and structural alignment. This indicates long-term architectural planning rather than random rebuilding. Engineers have compared aspects of Greek anti-seismic methods with Incan stonework at Machu Picchu, where flexible interlocking blocks absorb earthquake vibrations without collapsing. At Elefsina, stability was not just practical. Protecting the ritual chamber itself may have been considered sacred. What do you think truly happened inside the Telesterion? Was it ancient psychology, forgotten technology, or something humanity still doesn't fully understand? Share your thoughts in the comments below. Mother Shipton's cave hides a stream capable of turning ordinary objects into stone. Hats, shoes, teddy bears, even bicycles slowly harden beneath its water. For centuries, people believed the cave was cursed. Modern science proved the process is real, but still cannot fully explain why it works so perfectly. The cave became widely known during the 1600s after travelers documented strange petrified objects hanging beneath the spring. Early scholars believed the phenomenon was supernatural until chemical studies in the 18th and 19th centuries linked the process to mineral-rich water saturated with calcium carbonate. The greatest mystery surrounding Mother Shipton's cave is not the legend of prophecy, but the water itself. The cave's famous petrifying well can coat organic material in thick mineral layers at a speed that appears scientifically unnatural. In most limestone cave systems, Mineral structures such as stalactites grow extremely slowly, often less than 0.1 millimeters per year, meaning some formations require thousands of years to become visible. Yet at Mother Shipton's cave, objects can become heavily mineralized within only a few months. The spring water contains unusually high concentrations of dissolved calcium carbonate. As underground water moves through layers of magnesian limestone formed roughly 250 million years ago during the Permian period, it absorbs minerals under pressure. Once the water reaches open air, carbon dioxide rapidly escapes, forcing calcium carbonate to crystallize almost instantly onto nearby surfaces. Scientifically, the process resembles accelerated travertine formation, similar to what occurs at Pamukkale in Turkey or Mammoth Hot Springs in Yellowstone. However, the true mystery is stability. For this phenomenon to continue for centuries, the underground system must maintain an extremely precise balance involving mineral saturation, pH levels, water flow, pressure, and temperature. Even minor environmental fluctuations normally disrupt mineral precipitation systems. At Yellowstone, mineral terraces constantly change shape as water chemistry shifts. At Pamukkale, the white travertine pools form only under narrow environmental conditions. But Mother Shipton's cave behaves more like a miniature geological machine that has remained active for hundreds of years with unusual consistency. Researchers have measured calcium carbonate concentrations high enough to create rapid incrustation on exposed surfaces, yet nobody fully understands why the spring maintains such efficiency without major decline over centuries. Some geologists suspect deep underground channels continuously replenish dissolved minerals from hidden limestone reservoirs, while others believe microbial biofilms may stabilize crystal formation by acting like microscopic scaffolding that accelerates calcite deposition. Similar microbial activity has been observed in cave systems across Italy and Croatia, but the exact mechanism here remains unresolved. This is why some materials scientists compare the cave to a natural industrial coating system. Modern industries require controlled reactors, pressure regulation, and chemical stabilizers to reproduce comparable mineral deposition. Mother Shipton's cave performs the process naturally, continuously, and without machinery. Even more disturbing is the level of preservation. Many petrified objects retain delicate details beneath the mineral shell. Threads, textures, and surface patterns often remain recognizable long after mineralization. Normally, mineral replacement destroys fragile organic structures, but here the calcite crust sometimes acts as a protective shell before decay can occur. The process resembles fossilization compressed into human time scales, something that should not happen this quickly. The deeper scientists studied the cave, the stranger it became. The spring behaves less like a random geological feature and more like a self-regulating chemical reactor. Water emerges at nearly ideal conditions for rapid calcite precipitation, suggesting the underground hydrology is unusually stable. To create this effect naturally, several variables must remain synchronized simultaneously: high dissolved calcium concentration, elevated underground carbon dioxide, rapid CO2 release at the surface, stable water temperature, constant flow rate, and precise alkalinity levels. If one variable changes significantly, the petrification effect weakens. Yet records written by travelers centuries apart describe nearly identical results. This consistency is extremely unusual in hydrogeology. Scientists comparing the cave with other mineral springs noticed another anomaly. Mineral deposition occurs in concentrated localized zones, rather than spreading widely downstream. In many travertine systems, mineral precipitation gradually decreases over distance. But at Mother Shipton's cave, the process remains intensely focused near the spring itself. Some researchers suspect underground pressure dynamics may force supersaturated water upward unusually fast, preventing premature mineral release below ground, while others suggest microscopic surface roughness on hanging objects accelerates crystal nucleation. Even today, laboratory attempts to replicate the exact speed and texture of the cave's mineralization process often fail outside highly controlled environments. Nature still performs a process more efficiently than modern engineering. Long before chemistry existed, people feared the cave for a far simpler reason. Anything touching the water slowly turned into stone. To medieval populations, this appeared impossible. European folklore often linked unexplained geological phenomena to witchcraft, demons, or divine punishment. According to legend, Ursula Southisle, later known as Mother Shipton, was born inside the cave around 1488 and became England's most famous prophetess. Stories claimed violent storms erupted during her birth, while others described the cave as a gateway to dark supernatural forces. The petrifying water intensified those fears because, unlike earthquakes or volcanic eruptions, the process was slow and visible. People could literally watch ordinary objects become rock over time. That transformation deeply disturbed medieval observers because it appeared to violate the natural order. Even centuries later, the site still creates psychological discomfort. The human brain associates stone formation with immense geological timescales, so watching it happen within months feels unnatural, almost artificial. That reaction helped transform the cave into one of Britain's oldest tourist attractions. By the 17th century, visitors were already bringing personal objects to hang beneath the spring as demonstrations of the phenomenon. Long before modern museums existed, the cave had already turned science into spectacle. One controversial theory suggests ancient civilizations may have observed mineral systems like this and adapted the principles into lost engineering technologies. The Romans created marine concrete capable of surviving more than 2,000 years, partly because volcanic ash reacted chemically with seawater to form durable minerals such as aluminum tobermorite crystals. Persian engineers developed waterproof sarouge mortar that resisted harsh desert climates for centuries, while Nabatean builders at Petra mastered mineral-rich water management with extraordinary precision in one of the driest regions on Earth. Mother Shipton's cave raises an uncomfortable question. How much did ancient builders truly understand about natural mineral chemistry? The cave demonstrates that nature can create protective stone coatings automatically under the right conditions. If ancient engineers discovered methods to manipulate similar reactions, they may have produced materials far more advanced than historians assume. Some researchers studying biomineralization believe ancient craftsmen could have unknowingly exploited bacterial mineral growth, lime chemistry, and dissolved carbonate reactions through observation and experimentation rather than theoretical science. The idea becomes even more intriguing when examining ancient structures that resist weathering far beyond modern expectations. In several Roman harbours, mineral reactions actually strengthened concrete over time instead of weakening it. Mother Shipton's cave may represent the same principle operating in pure natural form. Do you think Mother Shipton's cave is simply a rare geological phenomenon? Or could ancient civilizations once understand natural mineral technology far better than we realize? Share your thoughts in the comments below. In the wetlands of central Sumatra, Indonesia, Moratacus stands where ancient brick structures should have already dissolved into mud centuries ago. Surrounded by tropical rain, acidic soil, floods and dense jungle, the complex has survived for nearly 1,000 years and no one fully understands how. Muara Takus was rediscovered during the 19th century by Dutch colonial researchers exploring the Kampar River region of Riau province. Archaeological investigations later revealed that the site likely belonged to the Buddhist sphere of the Srivijaya Empire between the 11th and 12th centuries. Unlike famous stone monuments such as Borobudur in Java or Angkor in Cambodia, Muara Takus was constructed primarily from red brick and river stone inside one of the harshest construction environments in Southeast Asia. That immediately created a mystery. In tropical rainforest climates, ancient brick architecture normally deteriorates rapidly because of constant humidity above 80%, biological erosion from moss and roots, acidic groundwater, heavy monsoon rainfall, and unstable swamp-like soil. Yet major portions of Muara Takus still remain structurally intact. The question became unavoidable. What exactly did the builders know that modern historians still do not? The greatest technological mystery of Muara Takus is its brickwork. At first glance, the bricks appear relatively simple, but scientific analysis revealed unusual durability compared to ordinary medieval tropical construction materials. Many sections resisted cracking, moisture penetration, and biological decay far longer than expected. This is highly abnormal. Modern studies of tropical erosion show that brick structures exposed continuously to rainforest climates can experience severe material degradation within only a few centuries, especially without modern waterproofing systems. Sumatra's annual rainfall often exceeds 2,500 to 3,000 millimeters in some regions, and when combined with constant heat and humidity, this creates one of the most destructive architectural environments on Earth. Yet, Muara Takus survived. Researchers believe several factors may explain this impossible durability. First, the bricks may have been fired at unusually high temperatures. High-temperature firing changes the internal crystalline structure of clay, reducing porosity and improving water resistance. Some surviving bricks from Muara Takus display density levels comparable to later industrial kiln-fired materials. Second, the clay composition itself appears unusual. Geological surveys suggest the builders may have selected silica-rich river sediments rather than ordinary surface clay, because silica increases hardness and thermal stability when properly heated. Third, there are theories that organic additives were mixed into the mortar or clay before firing. Similar ancient techniques existed elsewhere in the ancient world, including sticky rice mortar in China, volcanic ash concrete in Rome, plant resin waterproofing in India, and palm sugar compounds in Southeast Asian masonry. If Muara Takus used a lost organic binding formula, the recipe has disappeared completely. Even more mysterious is the scale of production. The site required enormous quantities of brick, yet archaeologists have found surprisingly little evidence of industrial kiln zones nearby. No massive permanent firing complexes comparable to Roman or Chinese production centres have been conclusively identified. So where were the bricks manufactured? Some researchers believe the bricks may have been produced seasonally along riverbanks and transported through the Kampar River system using large cargo boats. Others suspect there are still buried industrial zones hidden beneath the surrounding jungle and sediment. The durability of the bricks has drawn comparisons with several ancient engineering anomalies worldwide, including Roman marine concrete surviving 2,000 years in seawater, Maya-lime plaster resisting tropical decay, Khmer hydraulic stonework at Angkor, and the volcanic pozzolana mixtures used in Mediterranean architecture. But Muara Takus remains different because its primary defense was not stone. It was brick surviving a rainforest, and that should have been nearly impossible. The second major mystery lies beneath the structures. Muara Takus was built near rivers, wetlands, and flood-prone terrain. where heavy architecture normally sinks or fractures because saturated soil shifts constantly over time. Modern engineers spend enormous resources stabilizing structures in swamp regions, using deep piling systems, compacted layers, drainage engineering, and geotextile reinforcement. Yet ancient builders at Muaratakus somehow created foundations stable enough to survive centuries of monsoon cycles. Excavations indicate that the builders may have used layered soil compaction combined with sand and gravel stabilization techniques. Some archaeologists also suspect organic reinforcement materials such as hardwood platforms or charcoal layers may exist beneath the foundations. This possibility is remarkable because charcoal stabilization is now recognized in modern geotechnical engineering for moisture control and soil conditioning. The engineering similarities are difficult to ignore. At Angkor in Cambodia, massive temples relied on controlled hydraulic systems to stabilize water pressure beneath the city. In Venice, medieval engineers used submerged timber foundations to prevent collapse in wet terrain. The Maya also elevated ceremonial platforms above swampy ground using layered fill systems. Muaratakus appears to belong to this same category of advanced environmental engineering, but developed independently inside the rainforests of Sumatra. Another unresolved mystery is transportation. The temple complex required thousands of tons of material, including brick, stone, and ceremonial construction elements, but the surrounding region was dominated by jungle and waterways rather than roads. How did medieval builders move such massive quantities of material through rainforest terrain? Historians believe the answer may lie in the forgotten river civilization of Srivijaya. Unlike land-based empires, Srivijaya controlled maritime and river trade routes across Southeast Asia between the 7th and 13th centuries. Chinese records describe Srivijaya as a powerful naval trading state connected to India and China through extensive shipping networks. Muaratakus may represent the inland extension of this water-based civilization. Some researchers propose that construction materials were transported during seasonal flood cycles when river depth increased dramatically. Large wooden barges could have moved heavy cargo deep into the interior using natural waterways as logistical highways. Satellite mapping has also revealed ancient river channels surrounding the region, raising speculation that portions of the hydraulic landscape may have been artificially modified long before modern engineering. If true, the builders of Muaratakus may have understood seasonal hydrology with astonishing precision. Although much of the complex has been damaged over time, several structural alignments appear deliberate rather than random. Researchers have observed possible orientation patterns connected to solar positioning, seasonal cycles, and Buddhist ritual geometry. This was common in ancient civilizations. Egyptian temples aligned with solstices, Maya pyramids tracked equinox shadows, Angkor Wat aligned with cosmic Hindu symbolism, and Borobudur encoded Buddhist cosmology into architectural form. Muaratakus may represent a Sumatran variation of this ancient tradition. What makes the site difficult to study is the environment itself. Dense rainforest severely limits long-distance visibility, making astronomical observation far more challenging than in deserts or open plains. Yet some alignments remain surprisingly accurate. This suggests the builders conducted long-term sky observations despite the difficult tropical climate. Perhaps the strangest mystery is what disappeared. If Muaratakus was truly an important Srivijaya religious center, where is the city that supported it? Unlike Angkor or Borobudur, very little urban infrastructure survives around the site. Archaeologists have not discovered large residential districts, defensive walls, or major population centers nearby. One explanation is material decay. Most settlements in tropical Southeast Asia were built largely from wood and bamboo rather than stone. In humid rainforest conditions, organic structures can vanish almost completely within centuries. Another theory involves environmental transformation. Changes in river routes, flooding patterns, trade networks, or climate conditions may have forced abandonment of the region. Once maintenance stopped, the rainforest rapidly reclaimed the landscape. Modern ground-penetrating surveys continue to detect buried anomalies beneath the surrounding terrain, suggesting that much of ancient Muara may still remain underground, waiting beneath the jungle. Do you think Muara was just a single forgotten temple, or the last surviving trace of an advanced rainforest civilization we still haven't uncovered? Share your thoughts in the comments below. Beside Sigiriya stands a forgotten mountain filled with ruined monasteries, precision-cut stone platforms, drainage systems carved into solid rock, and the remains of a gigantic reclining Buddha built on the edge of a 200-meter cliff. Even today, archaeologists still debate how ancient builders transported materials, stabilized massive structures, and protected them from one of the harshest tropical climates in South Asia. Although local monks had known the site for centuries, systematic archaeological attention increased during the 19th and 20th centuries as British-era surveys around Sigiriya revealed that Pidurangala was not an isolated monastery, but part of a much larger engineered sacred landscape dating back more than 1,500 years, primarily linked to the reign of King Kashyapa in the 5th century CE. The first mystery begins with the mountain itself. Pidurangala is not simply a hill with ruins on top. It is a giant column of ancient granite formed hundreds of millions of years ago, surrounded by unstable slopes, fractured rock faces, and enormous detached boulders. One of the most puzzling features is the massive balancing rock near the summit. The stone appears almost unstable, yet it has survived monsoon rains, thermal expansion, earthquakes, and centuries of erosion without collapsing. Ancient builders then chose to construct religious structures directly beneath and around it. Modern engineers say this required a sophisticated understanding of load distribution and geological stability. Even a small miscalculation could have triggered catastrophic rockfalls. The builders somehow identified which surfaces could support weight and which cracks would remain stable over centuries. Researchers often compare this to the mountain engineering seen at Machu Picchu, where the Inca cut structures directly into fault lines to improve earthquake resistance. Similar comparisons are also made with Meteora, where monasteries were placed atop unstable rock towers, but Pidurangala presents an even stranger problem: tropical weathering. Sri Lanka's central region experiences intense seasonal rainfall, often exceeding 2,000 millimeters annually. Water infiltration normally destroys cliffside structures over long periods, yet many stone-cut surfaces at Pidurangala remain remarkably intact. The pathways and cave systems of Pidurangala reveal another engineering mystery. Across the mountain are stone stairways, flattened meditation platforms, and drip ledges carved directly into granite. These drip ledges are particularly important. Ancient builders cut narrow grooves above cave entrances to redirect rainwater away from the interior. The technique sounds simple, but achieving consistent drainage angles on curved granite surfaces without modern surveying tools would have been extremely difficult. Some carved surfaces remain nearly level despite being created on steep inclines. Archaeologists studying the site found evidence of repeated stone polishing and controlled cutting, suggesting workers may have used combinations of iron chisels, abrasion sand, and water-assisted grinding techniques. The precision resembles the stone finishing found in parts of Sigiriya and even certain Buddhist cave complexes in India such as Ajanta caves. Yet Pidurangala's builders worked under more dangerous conditions, often directly beside vertical drops. One unanswered question remains: how did they maintain geometric accuracy at such heights? Even today, modern restorers struggle to transport equipment safely up the mountain. One of the greatest threats to ancient architecture is moisture. Tropical climates rapidly destroy mortar, pigments, brick and plaster through constant humidity, biological growth and thermal stress. Yet sections of Pitarangula's ancient construction survived for over 1,500 years. This has led scientists to investigate the composition of its mortar and surface coatings. Samples from related Sri Lankan ancient sites show mixtures containing lime, clay, ash, and finely crushed minerals that may have created hydraulic reactions similar to primitive cement. Some researchers believe organic compounds from plants or tree resins could also have been added to improve water resistance. This is important because many surviving structures at Pitarangula sit directly exposed to monsoon storms. Unlike enclosed temples, these ruins endure open-air weathering year after year. Comparisons are frequently made with Roman concrete used in structures like Pantheon. Roman marine concrete became stronger through long-term mineral reactions with water. While Pitarangula's materials are chemically different, the principle may be similar. Ancient builders unintentionally created compounds that improve durability over time instead of weakening. Some surviving plaster fragments at the site still cling tightly to bare rock despite centuries of root invasion and temperature shifts. For material scientists, that is deeply unusual. The most mysterious feature of Pitarangula may be the enormous reclining Buddha near the summit. The statue, approximately 12.5 meters long, was not carved from a single block of stone. Instead, it was constructed using layered brickwork covered with plaster and pigments. That decision creates a major engineering puzzle. Large horizontal statues are structurally unstable by nature. Weight accumulates unevenly across the torso, shoulders, and extended sections. In tropical climates, brick absorbs moisture, expands under heat, and contracts repeatedly over centuries. Without proper stress distribution, fractures would spread rapidly through the structure. Yet parts of the statue survived for well over a millennium. Modern structural engineers examining similar ancient Buddhist statues note that builders may have intentionally designed internal brick patterns to redirect pressure toward thicker support zones beneath the torso. Some theories suggest hidden internal chambers or density variations inside the brick core helped reduce cracking. This becomes even more remarkable considering the statue sits atop a mountain exposed to wind, rain, and dramatic temperature changes between day and night. Every expansion cycle should have weakened the outer plaster, but traces of ancient surface layers still remain. Pigment analysis from related Sri Lankan Buddhist sites revealed the use of mineral-based reds, yellows, and whites derived from iron oxides and lime compounds. These pigments are chemically stable and resist ultraviolet degradation far better than many organic paints. Similar long-lasting mineral coloration appears in Ajanta caves and ancient Egyptian tombs. What fascinates researchers most is the combination of aesthetics and engineering. The reclining Buddha was not merely decorative. Its builders appear to have understood mass distribution, thermal behavior, water runoff, and material fatigue centuries before modern structural science formally described those concepts. Even more mysterious is the logistics behind the project. Thousands of bricks, water, plaster materials, and pigments had to be carried nearly 200 meters upward across dangerous stone terrain. There is no surviving evidence of large ramps or mechanical lifting systems. Reconstructing the statue today using only ancient technology would still be an enormous challenge. Many archaeologists now believe Pitarangula and Sigiriya were designed as interconnected sites rather than independent monuments. From the summit of Pitarangula, the entire Sigiriya fortress becomes visible with astonishing clarity. The positioning is so precise that some researchers suspect intentional landscape planning. Sigiriya itself contains advanced hydraulic systems, symmetrical gardens, reservoirs, and water pressure engineering that still impress modern experts. Pitarangula may have functioned as the spiritual counterpart to that royal complex, a mountain monastery strategically overlooking the king's fortress. Some alignments between structures and solar movement have also fueled speculation about astronomical planning. While no definitive evidence proves the site was an observatory, several pathways and viewpoints appear intentionally oriented towards sunrise and seasonal light patterns. Ancient civilizations from the Maya to the Egyptians frequently integrated astronomy into architecture. The possibility that Sri Lankan builders employed similar principles raises difficult questions about the true sophistication of early South Asian engineering traditions. Even today, climbing Pidirangala Rock is difficult, yet more than 1,500 years ago, ancient builders somehow carried bricks, timber, water, plaster and tools to the summit repeatedly during construction. Unlike the pyramids of Egypt, there is no evidence of giant ramps or advanced lifting machines. Some historians believe workers used wooden scaffolding and rope pulley systems made from plant fibers, while others think materials were passed by hand along narrow cliff paths. But none of these theories fully explain how such large structures were built on top of a steep mountain. That is why Pidirangala remains one of Asia's most underrated ancient engineering mysteries. What do you think was the greatest secret of Pidirangala Rock? Let us know in the comments below. The island of Latte Stone Quarries still holds massive stone pillars capable of surviving Pacific typhoons, earthquakes, humidity, and centuries of erosion. Some weigh more than 30 tons. No metal cranes, no wheels, no written engineering system. Yet the ancient Chamorro people built structures that modern researchers still struggle to fully explain. Archaeologists first began seriously documenting Guam's latte stones during Spanish colonial surveys in the 17th and 18th centuries, but large-scale scientific excavation accelerated in the 1900s after American researchers mapped quarry sites hidden in forests and limestone hills. What shocked them was not just the size of the stones, but the precision of the engineering. Some unfinished pillars still remain attached to quarry bedrock, revealing evidence of systematic extraction methods rather than random carving. Latte stones are unlike almost any other megalithic structure on Earth. Each monument typically consists of two parts: a vertical limestone or basalt shaft called the haligi, and a rounded capstone known as the tarsa. Together, they formed elevated foundation for ancient Chamorro buildings between roughly 900 and 1700 CE. Some shafts exceed 4 meters in height and weigh between 10 and 30 tons. But the greatest mystery is not their size, it is their geometry. The rounded tarsa sections were shaped into near-symmetrical hemispheres with surprisingly balanced curvature. Modern measurements at several quarry sites show variations of only a few centimeters across large circular surfaces. That level of consistency is difficult even with metal tools. Yet the Chamorro people had no iron technology. Researchers comparing the quarry marks to Polynesian and Micronesian stoneworking traditions discovered something unusual. Most Pacific Island cultures using stone tools produced rough, fractured surfaces, but several latte stones display long grinding marks and smooth finishing patterns, more comparable to advanced stone polishing techniques seen in parts of the Roman world or at certain Incan sites in Peru. Some archaeologists believe basalt hammerstones combined with coral sand abrasion may have slowly shaped the surfaces over months or years. Others suspect thermal cracking methods may have been used, heating stone with fire before rapid cooling to create controlled fractures. However, no consensus exists because no surviving tools perfectly match the quarry marks. Even stranger, several unfinished latte stones suggest standardized proportions. The ratios between shaft diameter and capstone width appear repeated across multiple sites, implying the existence of engineering rules or inherited architectural templates. Transporting the stones may be even harder to explain than carving them. Guam's interior is filled with dense vegetation, steep volcanic terrain, and soft coastal soil. Yet latte stones were often moved kilometers away from quarry sites and aligned in remarkably straight rows. Experimental archaeologists attempted to drag replica stones across tropical ground using rope and log systems. The results were disastrous. Heavy stones sank into wet soil, shifted unpredictably, or cracked under uneven stress. Unlike the Egyptians, the Chamorro had no evidence of wheeled transport, draft animals, or large-scale road systems. Yet dozens of massive stone structures were successfully relocated and erected. One theory suggests the builders used seasonal conditions strategically, transporting stones during periods when the ground was firmer after dry weather. Another proposes lubrication systems involving coconut oil, wet vegetation, or rolling palm trunks, but none fully explain how rounded tarsa capstones were stabilized during movement. A slight imbalance could have caused catastrophic rolling accidents. The engineering challenge becomes even more mysterious when compared to other ancient cultures. The average Easter Island moai weighs around 13 tons. Many latte components fall within similar weight ranges, yet Guam's humid terrain is far more unstable than the volcanic plains of Rapa Nui. This may be the most astonishing mystery of all. Guam sits in one of the most geologically violent regions of the Pacific. The island experiences earthquakes from nearby tectonic activity and is frequently struck by super typhoons with winds exceeding 250 kilometers per hour. Modern reinforced buildings have collapsed during some storms, yet many latte stones remained standing for centuries. Engineers studying the structures noticed something unexpected. The design itself may function as a primitive shock distribution system. The rounded tarsa capstones potentially reduced horizontal stress by allowing subtle load redistribution during seismic movement. Instead of rigidly locking the upper structure in place, the curved geometry may have helped absorb vibrations and wind energy. Some structural analysts compare the concept to primitive base isolation principles used in modern earthquake-resistant architecture. In modern engineering, flexible support systems help buildings dissipate seismic forces rather than resisting them directly. Surprisingly, latte stones may have unintentionally achieved a similar effect through shape alone. The elevated design also protected wooden structures from flooding, insects, and ground moisture. Air circulation beneath houses reduced humidity damage in Guam's tropical climate. This means the system was not merely symbolic and clept, it solved multiple environmental problems simultaneously. Comparisons with other ancient civilizations make the achievement even more remarkable. Roman columns were highly stable but depended on rigid compression systems. Japanese pagodas survive earthquakes using central flexible columns called shinbashira. The latte stone system appears to represent a completely different engineering philosophy, developed independently in the Pacific. Some researchers argue the Chamorro may have accumulated centuries of observational knowledge about storm behavior and structural balance. Without mathematics or written physics, they may still have discovered empirical engineering principles through repeated experimentation across generations. No written records survive explaining how the system was designed. Yet the stones themselves continue to function like silent engineering prototypes, tested by nature for hundreds of years. At several quarry locations, archaeologists discovered partially detached stones still connected to bedrock. These unfinished pieces provide rare insight into the extraction process. What confuses researchers are the unusually straight grooves cut into limestone surfaces. Coral limestone is notoriously unpredictable when fractured manually. It tends to crumble irregularly rather than split cleanly. Yet some quarry channels appear surprisingly controlled. Microscopic analysis revealed repeated abrasion patterns that may indicate rotational grinding motions rather than simple hammer strikes. This suggests the possibility of sophisticated, repetitive carving techniques. Several surfaces also show polishing levels difficult to explain in a tropical outdoor environment. Wind erosion and salt exposure should have degraded the finish rapidly. Yet portions remain relatively smooth even after centuries. Some scientists compare the weather resistance of certain latte stones to Roman marine concrete, which also gained unusual durability from mineral interactions with salt water. Guam's limestone may have undergone natural chemical hardening over time due to oceanic exposure, though this theory remains debated. The Tasacap stones remain one of the greatest unanswered questions. If the purpose was purely structural, flat surfaces would have been easier to carve, easier to transport, and more stable. Instead, the Chamorro deliberately created rounded hemispheres requiring vastly greater labour. One practical explanation claims the shape prevented rats from climbing into elevated food storage houses. Similar anti-rodent architectural solutions exist in parts of Southeast Asia, but many researchers believe this alone cannot justify the extreme precision and enormous effort involved. Another theory proposes astronomical or ceremonial meaning. Certain latte alignments may correspond loosely with seasonal solar directions or prevailing wind patterns. Others suggest the rounded forms symbolized cosmological concepts connected to ancestry or navigation. The Chamorro were among the Pacific's most advanced navigators. European sailors in the 18th century were stunned by the speed and maneuverability of Chamorro flying proa vessels, some of which reportedly outperformed European ships under specific wind conditions. That raises an unsettling possibility. The same understanding of balance, weight distribution, aerodynamics, and environmental forces used to master long-distance ocean travel may also have influenced the engineering of latte stones. If true, these monuments were not primitive constructions at all, but products of a deeply specialized knowledge system now almost completely lost. What do you think the rounded Tasacap stones were really designed for? Simple protection, advanced engineering, or something far more mysterious? Share your theory in the comments below. Northeastern Thailand hides one of the strangest engineering sites of the ancient Khmer Empire, Phimai Historical Park. More than 250 kilometers from Angkor Wat, the complex was built mainly between the 11th and 12th centuries during the reigns of Suryavarman and Jayavarman VII. Yet despite being outside Cambodia, Phimai was connected directly to Angkor through an enormous royal road system, stretching roughly 225 to 250 kilometers. The site was first systematically documented by French explorers and archaeologists during the late 19th and early 20th centuries as part of broader Khmer studies across Southeast Asia. Excavations later revealed something unexpected. This was not a provincial outpost. Phimai may have been one of the most technologically advanced urban centers in mainland Asia during the medieval period. What shocked researchers was not only the scale of the ruins, but the precision hidden inside them. Massive sandstone blocks fit together with almost no visible gaps. Drainage systems still function after nearly 1,000 years. Entire corridors align with sunlight in ways that resemble astronomical architecture found thousands of kilometers away in places like Chichen Itza and Newgrange. And the deeper archaeologists investigated Phimai, the more impossible the site began to look. Most major Khmer Hindu temples were designed facing east, symbolizing sunrise and cosmic rebirth. But Phimai breaks that rule completely. Its main axis points southeast, almost directly toward Angkor. For decades, researchers debated whether this was symbolic, political, or astronomical. Satellite measurements showed that the orientation was too deliberate to be accidental. Some scholars proposed that Phimai was intentionally aligned with the Khmer Imperial Road network, creating a sacred geographical connection between Thailand and Cambodia. The precision becomes more mysterious when considering the tools available at the time. Medieval Khmer engineers had no GPS, no magnetic compasses as used later in maritime navigation, and no modern surveying instruments. Yet the alignment errors across parts of the complex are measured in fractions of a degree. Comparisons are often made with Roman surveying techniques or the solar alignments at Machu Picchu. But unlike Roman roads, which relied heavily on standardized military engineering manuals, the Khmer system still lacks surviving technical documentation. Nobody fully understands how they achieved this accuracy across hundreds of kilometers of jungle terrain. One of the greatest mysteries at Phimai is the stonework itself. Many sandstone blocks were cut so precisely that modern researchers struggle to insert thin blades between the joints. Some sections appear almost machine-fitted despite being created nearly 1,000 years ago. The average sandstone block at Phimai weighs several hundred kilograms, while larger architectural pieces weigh multiple tons. Yet many are stacked high above ground level with remarkable balance and stability. No evidence of advanced pulley cranes or wheeled transport systems has been found at the site. Researchers comparing Khmer construction to Egyptian pyramid masonry noticed a major difference. Egyptian structures often relied on enormous mass and angled load distribution. Khmer builders, however, achieved structural endurance through interlocking geometry and carefully controlled weight transfer. Even more puzzling is the durability. Northeast Thailand experiences intense monsoon cycles, seasonal flooding, humidity fluctuations, and biological erosion. Modern concrete in tropical climates can crack within decades without maintenance. Yet many Phimai joints remain stable after centuries. Some engineers believe Khmer architects may have intentionally designed gravity locking systems, where the weight of upper stones compressed lower layers in ways that minimize lateral stress. Similar concepts exist in Inca stonework at Machu Picchu, though the cultures were separated by oceans and centuries. Archaeological surveys and satellite imaging reveal that Phimai was part of a massive transportation system connected directly to Angkor. Along the route were bridges, reservoirs, rest stations, and elevated roadbeds engineered to survive monsoon flooding. Some sections of the ancient road remain astonishingly straight, even after centuries of jungle growth. LiDAR scans in Cambodia and Thailand suggest that the Khmer Empire may have managed one of the largest pre-industrial infrastructure systems on Earth. This creates a logistical mystery. Transporting sandstone alone would have required enormous labor coordination. Some stones may have originated dozens of kilometers away. Without steel machinery or modern vehicles, the Khmer builders somehow moved, carved, and positioned millions of kilograms of material with extraordinary precision. For comparison, medieval European kingdoms during the same era often struggled to maintain paved roads outside major cities. Yet the Khmer Empire maintained hydraulic cities and long-distance transport corridors across tropical terrain. Some historians now argue that the Khmer state functioned less like a medieval kingdom and more like a highly organized engineering civilization. Perhaps the most underestimated technology at Phimai lies underground. The temple was built in a flood-prone environment with unstable seasonal soil conditions. Normally, structures this heavy should experience gradual sinking, cracking, or foundation displacement over centuries. Yet major parts of Phimai remain standing with surprising structural integrity. Excavations revealed compacted laterite foundations beneath the temple complex. Laterite hardens dramatically after exposure to air, functioning almost like natural concrete. Khmer engineers appear to have understood exactly how to exploit this property. Even more impressive was the drainage system. Channels beneath parts of the structure redirected rainwater away from load-bearing foundations. Some archaeologists compare the sophistication of this hydraulic planning to Roman bath engineering or Persian qanat systems. The comparison becomes even more remarkable when looking at Angkor itself. Satellite studies published in the 21st century reveal that Angkor possessed one of the largest urban hydraulic systems in pre-modern history, covering nearly 1,000 square kilometers. Phimai may have functioned as a northern extension of this technological network. What remains unclear is how Khmer engineers modeled water behavior so effectively without modern hydrology. Certain corridors at Phimai allow sunlight to pass through multiple gateways in near-perfect alignment during specific times of the year. Researchers still debate whether these alignments were intentional religious symbolism or part of more advanced astronomical system. The phenomenon resembles structures found at Chichen Itza, where shadows create the illusion of a descending serpent during equinoxes, or Newgrange in Ireland, where winter solstice sunlight illuminates an inner chamber with extraordinary precision. To achieve this, ancient builders needed long-term observations of solar movement across seasons. Even small angular errors would ruin the effect. Some measurements at Phimai show alignments accurate to within extremely narrow margins. This implies repeated astronomical tracking over generations. Yet no surviving Khmer text fully explains the mathematical methods behind these calculations. The mystery deepens because Khmer civilization blended Hindu cosmology, Buddhist symbolism, and practical engineering into the same architecture. At Phimai, science and religion may have operated together as one unified system. The carvings across Phimai contain microscopic details that continue to puzzle stone specialists. Floral patterns repeat with extraordinary symmetry. Curved surfaces remain smooth despite centuries of erosion. Some decorative sections are only a few millimeters deep, yet preserve sharp edges. Experimental archaeologists attempted to recreate similar carvings using reconstructed iron tools from the Khmer period. The process proved extremely slow and physically demanding. Producing the entire decorative program at Phimai would have required enormous labor specialization and precise geometric planning. Some lintels also show polishing effects that resemble abrasive finishing techniques, more advanced than normally associated with medieval Southeast Asia. The scale adds another layer of mystery. Phimai was not a single isolated temple. It was part of a civilization constructing massive stone complexes simultaneously across the Khmer Empire. Coordinating artistic consistency across hundreds of kilometers would have required highly organized workshops and standardized engineering knowledge. Do you think the Khmer Empire possessed engineering knowledge far beyond what historians once believed? Share your thoughts and theories in the comments below. Beneath Colchester Castle lies the hidden core of the massive Temple of Claudius, a structure so overbuilt, so resistant to moisture and collapse, that it has silently supported an entire medieval castle for nearly 1,000 years. Built above the oldest recorded Roman city in Britain, the site remains one of the strangest engineering mysteries in Europe. Even today, archaeologists still debate whether Roman engineers in Britain possessed construction knowledge far beyond what historians once believed. The first clues emerged during excavations in the 18th and 19th centuries, when workers digging beneath the castle uncovered enormous Roman foundations, thick vaults, burnt destruction layers, and strange bricks that showed almost no serious decay despite nearly 2,000 years underground. Later archaeological surveys confirmed that the Norman castle had not been built from scratch. Instead, it had been constructed directly on top of the Roman Temple of Claudius, a gigantic imperial monument erected shortly after the Roman conquest of Britain in AD 43. What makes the site extraordinary is scale. The Roman podium beneath Colchester Castle measures roughly 24 by 32 meters, with foundations several meters thick. For comparison, many Roman temples in northern Europe used relatively shallow foundations because transporting stone and mortar across frontier provinces was difficult. Yet at Colchester, engineers built something closer to the massive imperial architecture normally seen in Rome itself. Historians still question why such an enormous structure was constructed in a recently conquered territory vulnerable to rebellion and attack. The answer may connect to politics, fear, and engineering experimentation. Camulodunum, the Roman name for Colchester, was the first Roman capital of Britain. The Temple of Claudius symbolized Roman domination over native tribes. But only at around 2 decades after its completion, the city became the center of one of the most violent uprisings in Roman history, the Revolt of Boudicca in AD 60 or 61. Ancient historian Tacitus described how the city was overwhelmed and burned. Archaeologists later discovered thick black destruction layers beneath the castle containing charcoal, ash, collapsed masonry, and melted material from the inferno. Yet strangely, parts of the Roman structure survived the catastrophe astonishingly well. Some researchers believe the survival came from the unusual Roman concrete mixture used beneath the temple. Analyses of surviving mortar samples show traces of crushed tile, lime, sand, and pozzolanic components similar to those found in long-lasting Roman marine concrete. Modern engineers know that pozzolanic reactions can continue strengthening material over time through chemical interaction with moisture. In some cases, exposure to heat can even trigger additional mineral bonding inside the structure. That possibility has transformed Colchester into an important case study for scientists researching ancient concrete durability. While modern Portland cement often begins serious chemical degradation within 50 to 100 years under wet conditions, some Roman materials at Colchester have endured almost 20 centuries in cold, damp British soil. But the greatest mystery at the site may not be the concrete. It may be the bricks. Deep beneath the castle are Roman bricks that should not still exist in such condition. Colchester experiences constant moisture, seasonal freezing, groundwater exposure, and temperature shifts that normally destroy porous ancient materials over time. Medieval bricks in Britain frequently cracked, absorbed water, or weakened after only a few centuries. Yet many Roman bricks below Colchester remain remarkably dense and structurally stable. Laboratory examinations suggest the Romans fired these bricks at unusually consistent temperatures, possibly exceeding 900 degrees Celsius. Achieving that level of uniformity in ancient kilns would have required highly controlled airflow and sophisticated firing management. Some samples also contain elevated silica and vitrified mineral structures that reduced water absorption and limited freeze-thaw cracking. In modern engineering terms, the bricks behaved almost like low-porosity ceramic composites. That is deeply unusual for a frontier province of the Roman Empire. Similar durability has only been observed at a few major Roman sites, including parts of the Pantheon and Roman harbour structures near Naples. Yet Britain lacked the volcanic ash sources available in Italy, forcing Roman engineers to adapt using local materials. Exactly how they achieved such long-term moisture resistance in Britain's wet climate remains partially unresolved. Some archaeologists believe the answer lies in a lost regional manufacturing process. Others suspect Roman builders carefully selected clay sources with naturally high mineral stability. There are even theories suggesting repeated kiln cycling created partial vitrification inside the bricks, forming microscopic glass-like structures that dramatically slowed water penetration. Whatever the explanation, the results were extraordinary. The Norman builders who arrived after 1066 clearly recognized the strength of the Roman platform beneath them. Instead of demolishing the ancient ruins, they reused them as the foundation for what became the largest Norman keep ever constructed in Britain. Colchester Castle stretches roughly 46 metres long and over 33 metres wide, making it significantly larger than the White Tower of the Tower of London in overall footprint. The weight pressing onto the Roman remains is immense, and yet the Roman foundations still hold. This has led structural historians to question whether Roman engineers intentionally over-designed the temple base far beyond immediate architectural needs. Some believe the foundation system distributed pressure through layered rubble, brick and mortar in ways comparable to primitive load-balancing engineering. Ground-penetrating radar surveys suggest some buried sections may extend deeper than previously expected, though full excavation remains impossible because removing the castle above would risk catastrophic instability. Then there are the underground chambers. Beneath parts of the castle lie vaulted Roman spaces with geometric precision that continues to puzzle researchers. Laser surveys have revealed curvature deviations, measuring only millimeters across large sections of surviving vaults. Achieving such symmetry without modern optical tools would have required advanced surveying methods and highly disciplined construction teams. Some historians argue Roman military engineers brought elite architectural knowledge directly from continental Europe to Britain. Others think Colchester may have served as a testing ground for imperial construction techniques adapted for unstable northern climates. The mystery deepens further when examining moisture control. Even after centuries underground, some Roman chambers remain unexpectedly dry compared to surrounding soil conditions. Researchers have identified drainage gradients and layered material transitions that appear deliberately designed to redirect groundwater away from structural cores. Similar concepts exist in modern foundation waterproofing systems. If true, Roman engineers may have understood hydrostatic pressure behavior in far greater detail than previously assumed. Another unresolved puzzle involves rumored tunnels extending beyond the castle itself. Antiquarian reports from the 19th century describe sealed passages beneath Colchester leading away from the Roman temple complex. Some collapsed sections were closed permanently due to fears of subsidence. Ground surveys hint that additional buried structures may still exist beneath the modern town, but urban development has made large-scale excavation nearly impossible. No one knows how extensive the underground system originally was. What do you think made these Roman structures survive for nearly 2,000 years beneath Colchester Castle? Lost engineering knowledge, extraordinary materials, or something we still don't fully understand? Let us know your thoughts in the comments below. The tiny sacred island of Delos, standing in the middle of the Aegean Sea, became the site of one of the strangest ceremonial structures of the ancient world, the Terrace of the Lions. Archaeologists first systematically documented the site in 1873 during excavations led by the French school at Athens. Buried beneath centuries of debris and weather erosion, the marble lions appeared lined in a rigid formation facing the sacred lake of Delos, the legendary birthplace of Apollo. At first glance, they seemed like simple religious statues, but the deeper researchers investigated, the more the terrace began to resemble something far more advanced. A carefully engineered ritual complex combining astronomy, stone technology, transportation logistics, environmental durability, and psychological architecture in ways that still remain partially unexplained. The lions were carved around the 7th century BCE, likely by craftsmen from the island of Naxos. Ancient records suggest there may originally have been between 9 and 16 lions, though only a handful survive today. Each sculpture was carved from high-grade Naxian marble, one of the hardest and purest white marbles in the ancient Mediterranean. What immediately puzzled researchers was the astonishing consistency between the statues. Their body proportions, head angles, leg spacing, and posture alignments are almost identical. For ancient craftsmen working without modern measuring tools, producing multiple multi-ton stone sculptures with near-industrial uniformity should have been extraordinarily difficult. Modern surface analysis revealed repeating chisel patterns and precision groove depths that suggest the sculptors may have used standardized carving systems or measurement templates. Some archaeologists compared the consistency to modular construction techniques seen much later in Roman engineering. The lions appear less like individually crafted artworks and more like components manufactured according to a strict geometric system. This is highly unusual for the archaic Greek period, when sculpture was still believed to be transitioning from primitive forms into naturalistic design. Even more mysterious is the transportation problem. Naxos lies roughly 100 kilometers from Delos across open Aegean waters. Each lion likely weighed several tons before carving. Ancient workers would have needed to quarry the marble from mountain deposits, transport massive blocks downhill without iron cranes, move them onto wooden ships, survive unpredictable sea currents, unload them onto Delos, and then precisely position them along the ceremonial terrace. The engineering challenge becomes even more extreme when compared with other ancient transport mysteries. The Moai statues of Easter Island were moved across land using rope systems and manpower. The trilithon stones of Baalbek may have required Roman lifting technology. But the Terrace of the Lions demanded both maritime stability and precision unloading operations, centuries before the peak of Greek naval engineering. Some experimental archaeologists estimate that even transporting one unfinished marble lion across the Aegean using reconstructed ancient ships would have required advanced ballast control and careful wave timing. Yet the ancient Greeks somehow moved an entire ceremonial line of them. The placement of the lions may be the greatest mystery of all. The statues were not arranged randomly. They faced eastward toward the sacred lake, aligned along a processional route leading toward Apollo's sanctuary. Several archaeoastronomers studying Delos noticed that the orientation of the terrace corresponds closely with sunrise positions during important religious festivals associated with Apollo. During certain seasons, sunlight would strike the lions sequentially as dawn moved across the horizon, creating the illusion that the statues were gradually awakening in light. This has led some researchers to propose that the terrace functioned as a ritualized astronomical corridor rather than simple decoration. Similar ceremonial alignments appear at Stonehenge, the Temple of Karnak in Egypt, and Chaco Canyon in North America. But Delos is unusual because the astronomical effect may have been integrated directly into psychological movement. Pilgrims entering the sacred zone would walk beside a synchronized line of illuminated predators facing the rising sun. The architecture itself may have been designed to manipulate emotional perception, fear, reverence, submission, and awe, long before modern theories of environmental psychology existed. The lions themselves also raise symbolic questions. There were no native lion populations on Delos. In fact, lions had largely disappeared from mainland Greece centuries earlier. Yet throughout the ancient world, lions repeatedly appeared in sacred architecture connected to solar power, divine kingship, or threshold protection. The Lion Gate of Mycenae, the Lion Guardians of Mesopotamia, and Egyptian sphinxes all served as symbolic protectors between ordinary space and sacred territory. The Delos lions may have performed the same function, creating a controlled spiritual boundary around Apollo's birthplace. But unlike many ancient guardian statues, the Delos lions possess unusually aggressive anatomical styling. Their open mouths, stretched bodies, and forward-facing gaze create a visual compression effect when viewed from certain angles along the terrace. Modern architectural simulations suggest the spacing between statues may have been deliberately calibrated to intensify this visual effect for approaching pilgrims. In other words, the builders may have understood how repetitive geometry could psychologically amplify intimidation and sacred authority. Then there is the durability problem. Delos sits in a harsh marine environment exposed to salt air, intense UV radiation, seasonal storms, and temperature fluctuation. Marble normally deteriorates significantly under these conditions through granular disintegration and salt crystallization. Yet many portions of the lion survived over 2,500 years with recognizable anatomical detail still intact. Microscopic examinations detected unusual calcite recrystallization layers on parts of the marble surface. Some researchers believe repeated salt exposure naturally formed a protective mineral skin over time. Others argue the marble may have been intentionally polished or treated using organic compounds or mineral coatings now lost to history. Similar mysteries surround Roman marine concrete, which grows stronger in seawater, and certain Maya pigments that resisted tropical decay for centuries. If the Delos lions were intentionally treated, it would suggest ancient Greek craftsmen possessed a deeper understanding of material preservation than traditionally assumed. The broader island of Delos only deepens the mystery. Despite being small, rocky, and lacking major natural freshwater sources, Delos became one of the most important religious and commercial centers in the Mediterranean. Archaeologists uncovered sophisticated drainage systems, underground cisterns, hydraulic channels, and carefully engineered street grids across the island. Some water systems maintained pressure gradients despite uneven terrain, while certain foundations show evidence of anti-seismic stabilization methods using layered stone flexibility. This creates a larger unanswered question. How advanced was Greek engineering during the Archaic period really? Traditional history often portrays early Greece as technologically primitive compared to later Rome, but Delos challenges that assumption. The Terrace of the Lions demonstrates coordinated stone standardization, long-distance maritime logistics, environmental durability, astronomical orientation, and large-scale ceremonial urban planning centuries before many historians believe such integration was possible. Comparisons become unavoidable. The precision transport recalls the unfinished obelisk systems of Egypt. The ritual alignment resembles Newgrange and Stonehenge. The psychological corridor effect mirrors later Roman imperial architecture. The environmental resilience echoes Roman marine engineering. Yet the Terrace of the Lions predates many of these systems or developed independently from them. What do you think the Terrace of the Lions was truly built for? A sacred ritual pathway, an ancient astronomical system, or something far more advanced that historians still don't fully understand? Share your thoughts in the comments below. More than 1,400 meters above sea level on the western slopes of Mount Lawu in central Java, Indonesia, Setho Temple remained hidden for centuries beneath volcanic mist and dense tropical vegetation before Dutch colonial researchers documented the site in the 19th century. Archaeologists later confirmed that the complex dates to the late Majapahit era, around the 15th century, yet almost everything about its construction feels older, stranger, and technologically inconsistent with many other Javanese temples from the same period. Unlike the famous volcanic stone towers of Borobudur or Prambanan, Setho rises as a sequence of ascending terraces carved directly into a steep mountain slope, resembling a step pyramid more commonly associated with Mesoamerican civilizations than Southeast Asian Hindu architecture. The first mystery begins with the mountain itself. Mount Lawu is not an easy place to build. The region receives heavy tropical rainfall, thick fog covers the slopes for much of the year, and volcanic soil is highly unstable. Modern geologists explain that steep volcanic terrain is especially vulnerable to erosion and landslides because water rapidly penetrates porous ash-rich soil layers. Yet Setho Temple has remained structurally stable for over 500 years. The terraces still hold their alignment with remarkable precision despite centuries of monsoon rains and seismic activity. Engineers studying the site believe the builders understood advanced slope stabilization techniques long before such principles were formally documented in engineering science. What makes the structure extraordinary is the way the terraces distribute pressure across the mountainside. Rather than relying heavily on mortar, many sections appear to use tightly interlocked volcanic stones, positioned at angles that naturally redirect weight downward into the slope. Similar pressure locking methods are visible in the stonework of Machu Picchu, where Inca engineers built earthquake-resistant walls by allowing stones to shift slightly during seismic movement without collapsing. The civilizations had no known contact, yet both developed remarkably comparable structural solutions for mountainous terrain. At Setho, some retaining walls remain upright even after centuries of tropical water exposure that would normally weaken ancient masonry. Archaeological surveys also suggest the temple contains a hidden drainage system beneath the terraces. During intense rainstorms, water appears to disappear rapidly through narrow stone channels instead of accumulating against the foundations. Modern hydrological engineers consider drainage one of the most critical components of mountain construction because trapped water dramatically increases landslide risk. Some researchers estimate that without effective drainage, the terraces would have failed centuries ago under Java's annual rainfall, which can exceed 3,000 millimeters in mountainous regions. Yet much of the underground system remains buried or inaccessible, leaving experts uncertain how sophisticated the original engineering truly was. Another unexplained feature involves the selection of volcanic stone itself. Many of the blocks show unusually low levels of surface deterioration despite constant humidity. Tropical climates normally accelerate chemical weathering because water penetrates microscopic pores in stone and expands biological growth such as moss and lichen. However, several sections of Setho's masonry remain comparatively intact. Material analysts believe the builders may have deliberately selected denser volcanic andesite with lower water absorption properties. In some areas, the stones also appear shaped with tiny outward slopes and narrow micro-channels that redirect rainfall away from joints, reducing internal moisture build-up. These details resemble passive water management strategies found in later engineered fortifications, yet Setho predates many of them by centuries. The layout of the temple raises even deeper questions. Unlike most classical Javanese Hindu temples centered around towering sanctuaries, Setho progresses upward through a sequence of open terraces aligned along a central axis. From above, the structure resembles a ceremonial pathway ascending toward the mountain summit. Some historians argue this design reflects older indigenous mountain worship traditions merged with Hindu cosmology during the decline of the Majapahit Empire. Others believe the architecture served astronomical purposes in addition to ritual functions. Several researchers studying the orientation of the terraces observe that certain gateways align closely with seasonal solar positions. During specific times of the year, sunlight reportedly passes through multiple stone entrances at nearly perfect angles during sunrise. Ancient civilizations across the world often use solar alignments to regulate agricultural calendars and ceremonial events. Similar phenomena exist at Chichen Itza, where the Pyramid of El Castillo produces a serpent-shaped shadow during equinoxes, and at Stonehenge, where the monument aligns with the summer solstice sunrise. At Ketho, however, the exact intention behind these alignments remains uncertain because many original ceremonial records disappeared with the collapse of Majapahit power. The carvings found throughout the complex add another layer of mystery. Unlike the refined royal iconography seen in major Hindu temples, Ketho contains unusual reliefs involving fertility imagery, human figures, and symbolic motifs that appear tied to older animist traditions. Some depictions are considered highly unorthodox within mainstream Hindu temple art. Historians suspect the mountain sanctuary may have functioned as an esoteric ritual center, where local spiritual practices blended with imported Hindu beliefs. This hybridization reflects a transitional period in Javanese history, when political authority weakened and isolated mountain communities preserved older traditions outside royal control. Even more puzzling is the apparent absence of extensive written documentation describing the temple's construction techniques. The Majapahit Empire produced inscriptions, literature, and administrative records, yet none provide a detailed explanation of how complex mountain engineering projects like Setho were executed. This silence has led some researchers to speculate that much of the technical knowledge existed as orally transmitted expertise among specialized builder groups. Once those groups disappeared, the construction methods vanished with them. Modern archaeological technology has only deepened the mystery. Ground-penetrating surveys around Mount Lawu detected anomalies beneath several sections near the terraces, suggesting buried chambers or additional structural foundations. Local legends long claimed hidden tunnels existed beneath the mountain sanctuary, though no complete excavation has confirmed them. Because the terrain remains unstable and parts of the site are vulnerable to landslides, large-scale excavation has been limited. As a result, significant portions of the complex may still remain underground. The temple's location itself may not have been chosen purely for spiritual symbolism. Mountains with volcanic activity often produce unusual electromagnetic conditions due to mineral-rich rock formations beneath the surface. Some visitors and researchers have reported compass inconsistencies and strange atmospheric sensations around Mount Lawu, though no definitive scientific explanation connects these experiences directly to the temple. Still, ancient civilizations frequently selected high-altitude volcanic sites for sacred architecture, possibly because dramatic landscapes reinforce spiritual authority and cosmological beliefs. Comparisons with other ancient mountain complexes reveal how unusual Setho truly is. The terrace engineering resembles Inca stabilization systems in Peru. The ceremonial ascent recalls Mesoamerican step pyramids. The solar alignments parallel monuments in Britain and Egypt. Yet Setho emerged independently within the isolated volcanic landscapes of Java during the final centuries of one of Southeast Asia's greatest empires. This convergence of engineering ideas across disconnected civilizations remains one of archaeology's most fascinating patterns. Do you think the builders of Setho Temple possessed engineering knowledge far ahead of their time, or are modern historians still underestimating ancient civilizations? Share your thoughts in the comments below. High above Lake Titicaca at nearly 3,812 meters above sea level, on the cold and windswept island of Isla del Sol, stands one of the Andes' strangest ancient ruins. Archaeologists first documented the site in detail during expeditions in the late 19th and early 20th centuries, when explorers noticed that the ruins did not resemble a normal temple, fortress, or settlement. Instead, Chincana appeared to be a deliberately confusing maze of narrow corridors, sealed chambers, blind passages, and stone walls arranged in patterns that seemed almost irrational. From the beginning, researchers struggled to explain why an ancient civilization would invest enormous labor into constructing a structure that felt less like a city and more like a machine designed to disorient people. The mystery became even stranger because Chincana was built in one of the harshest environments imaginable. The air around Lake Titicaca contains roughly 40% less oxygen than sea level. Temperatures fluctuate dramatically between day and night, and transporting heavy stone across the lake would have required remarkable logistical coordination. Yet despite those conditions, the builders created a complex stone labyrinth that survived centuries of earthquakes, erosion, and severe Andean weather. One of the first unsolved engineering mysteries involves the layout itself. Most ancient ceremonial centers followed recognizable geometric patterns. Machu Picchu used carefully organized terraces and astronomical alignments. Teotihuacan followed massive urban grids aligned to celestial events. Even the underground chambers of Hippogeium of Halsaflieni displayed deliberate symmetry. Chincana does not behave that way. Some corridors abruptly terminate at blank walls. Others narrow to widths barely large enough for a person to pass. Certain chambers appear intentionally hidden from direct access, almost as if movement through the structure was meant to follow ritual rules rather than practical logic. Modern archaeologists propose that Chincana may have functioned as a ceremonial maze linked to initiation rites. However, this explanation created another problem. The complexity of the structure appears excessive even for ritual use. Laser mapping surveys of the surviving walls revealed multiple phases of construction, suggesting the site was repeatedly modified over long periods. Some stone sections are crude and uneven, while others display precision fitting associated with elite Andean masonry. This inconsistency led to theories that Chincana may have been inherited and expanded by multiple civilizations, possibly beginning before the Inca Empire itself. That possibility becomes more intriguing when researchers compare the site to Tiwanaku, the mysterious pre-Inca civilization located roughly 70 kilometers southeast of Lake Titicaca. Tiwanaku builders were famous for stonework so precise that razor blades reportedly cannot fit between certain joints. Some of the tighter masonry inside Chincana resembles reduced versions of those techniques. Yet unlike Tiwanaku's massive ceremonial plazas, Chincana compresses people into claustrophobic corridors and enclosed spaces. The psychological effect is completely different. Instead of inspiring awe through scale, the structure creates isolation, confusion, and sensory distortion. Acoustic engineers studying ancient ritual sites became interested in Chincana because several chambers produce unusual sound reflections. In narrow corridors, even quiet whispers can echo sharply through the stone passages. Experiments conducted in similar enclosed Andean structures showed that irregular stone angles can amplify certain frequencies while suppressing others. Researchers compared the phenomenon to the resonance chambers inside Newgrange in Ireland and the oracle chamber at the Hippogeium in Malta, where sound behaves in ways that strongly affect human perception. Some specialists believe Chincana's builders may have intentionally manipulated acoustics to create psychological effects during rituals. In darkness, with amplified echoes bouncing unpredictably through the maze, participants may have experienced intense disorientation that felt supernatural. Another major mystery involves thermal engineering. At nearly 3,812 meters elevation, temperatures around Lake Titicaca can swing rapidly from intense daytime sunlight to near-freezing nights. Stone structures normally crack under repeated thermal expansion and contraction, yet parts of Chincana remained stable for centuries. Geological studies suggest that builders selected dense volcanic and sedimentary stones capable of resisting stress fractures better than softer regional rock. Mortar traces found in some sections indicate the possible use of mineral-rich binding compounds, though researchers still debate whether these materials were local or imported. Transporting those stones onto Isla del Sol creates another unanswered question. Some blocks weigh several hundred kilograms. Even today, moving such material across steep island terrain without machinery would be extremely difficult. The Inca civilization famously used labor networks capable of moving multi-ton stones over mountains, but Chincana's isolated location complicates the logistics. Boats on Lake Titicaca were traditionally made from totora reeds, and while large reed vessels could transport heavy cargo, repeated stone transport operations would have required exceptional coordination and engineering knowledge. Comparisons are often made with the transportation mysteries of Sacsayhuaman, where stones weighing more than 100 tons were moved without wheels or iron tools. Chincana may represent a smaller but equally puzzling example of Andean transport engineering. The legends surrounding the site deepen the mystery further. Local traditions claim Chincana connected to underground tunnels running beneath Lake Titicaca itself. While there is no confirmed evidence of giant tunnels crossing the lake, ground-penetrating radar surveys around parts of Isla del Sol detected anomalies and hollow spaces beneath certain structures. Ancient Andean civilizations possessed sophisticated hydraulic knowledge, constructing underground canals and drainage systems with surprisingly accurate gradients. Some archaeologists suspect that at least portions of Chincana may conceal buried passages or water management systems still unexplored today. The tunnel legends may sound mythical, but similar discoveries elsewhere in the Andes forced researchers to reconsider ancient underground engineering. Near Cusco, hidden Inca tunnels known as chincanas were described in colonial records for centuries before modern exploration confirmed parts of their existence. Some passages reportedly connected temples, storage chambers, and ceremonial centers across large distances. If Chincana on Isla del Sol belonged to a wider network of sacred underground structures, it would dramatically change how historians understand communication and ritual movement within the Andes. One of the most controversial aspects of Chincana involves its potential astronomical purpose. Isla del Sol held enormous spiritual significance in Inca cosmology because it was believed to be the birthplace of the sun god Inti and the origin point of the first Inca ancestors. Researchers noticed that some openings and passage orientations align roughly with solar positions during solstices. Although not as mathematically precise as observatories like Chanquillo, the structure may still have functioned as a ceremonial calendar. In narrow chambers, beams of sunlight entering at specific times of year could have marked ritual dates with dramatic visual effects. Scientists also investigated magnetic anomalies reported around the site. Some survey teams recorded minor compass deviations near stone concentrations containing iron-rich minerals. While these anomalies are natural, they may have influenced why the location was chosen. Ancient civilizations frequently selected ritual sites based on unusual environmental characteristics, including acoustics, water flow, light behavior, or magnetic properties. Chincana may represent a combination of all four. What makes the site truly unsettling is that no single explanation fully works. It is too complex to be merely symbolic, too impractical to be residential, too enclosed to function as a normal fortress, and too psychologically engineered to dismiss as random architecture. Every corridor seems to imply intentional design choices tied to movement, sound, light, and perception. So what do you think Chincana truly was? A sacred ritual maze, an ancient psychological experiment, or part of a lost underground system far more advanced than we realize? Share your theory in the comments below. Discovered running southeast from Rome across the Italian peninsula, the Appian Way was first ordered in 312 BC by the Roman censor Appius Claudius Caecus. What began as a military road eventually stretched more than 580 kilometers toward Brindisi, becoming the most important transportation artery of the Roman Republic and later the Empire. Yet the real mystery is not its age. It is the fact that large sections of the road still survive after more than 2,300 years, while many modern highways collapse within decades. Beneath its massive basalt stones, lies one of the greatest unsolved engineering achievements of the ancient world. The first thing archaeologists noticed about the Appian Way was that it was built nothing like ordinary ancient roads. Excavations revealed a multi-layered structure almost identical to modern highway engineering. Roman builders first compacted earth, then added large stones, smaller gravel, lime mortar, volcanic ash concrete, and finally massive polygonal basalt slabs on top. In some sections, the total depth exceeds 1 meter. The road was also slightly curved upward at the center, allowing rainwater to drain naturally toward the sides. Modern civil engineers call this a camber system, and it remains standard in highway construction today. What makes this shocking is the lifespan comparison. Modern asphalt roads often require major repairs after 15 to 25 years due to cracking, water infiltration, and thermal expansion. Some concrete highways last around 40 years before reconstruction becomes necessary. The Appian Way has endured earthquakes, floods, wars, and millions of travelers for over 2 millennia. Certain segments near Rome still preserve their original paving stones. Researchers studying stress distribution found that the Roman layered design absorbed pressure more efficiently than many rigid modern road systems. Instead of resisting movement completely, the structure flexed slightly under weight and vibration, reducing catastrophic cracking. The basalt stones themselves present another mystery. Many slabs weigh several hundred kilograms, while others exceed 1 ton. Yet they were transported across long distances without engines, cranes, or hydraulic machinery. Ancient Roman records describe carts, pulleys, wooden rollers, and animal labor, but historians still debate how such an enormous logistical operation maintained precision across hundreds of kilometers. Some stones fit together so tightly that even modern measuring blades struggle to pass between them. Archaeologists have found wheel ruts carved into the stone surfaces, proving centuries of intense traffic. Despite this wear, much of the road remained structurally stable. The precision of Roman surveying adds another layer to the mystery. The Appian Way is famous for its unusually straight alignment. Instead of following natural terrain, Roman engineers cut through hills, drained marshes, and constructed elevated foundations to preserve direct routes. Achieving this across hundreds of kilometers without satellite mapping or laser equipment seems almost impossible by ancient standards. Roman surveyors used tools such as the groma for straight lines and the chorobates for leveling. However, the accuracy they achieved continues to astonish researchers. Some sections deviate only slightly over vast distances. Modern archaeologists, comparing Roman roads with early modern European roads, discovered that many medieval routes were actually less precise, despite being built more than 1,000 years later. This suggests Roman engineering knowledge may have been partially lost after the fall of the empire. One of the greatest unsolved technological mysteries surrounding the Appian Way is Roman concrete. Unlike modern Portland cement, Roman concrete used volcanic ash called pozzolana mixed with lime and water. Recent scientific studies reveal that this material behaves in ways modern concrete does not. Microscopic analysis found rare mineral crystals known as aluminous tobermorite forming inside ancient Roman concrete over centuries. These crystals actually strengthen the material over time. In 2017, researchers studying Roman marine concrete discovered that seawater interacting with volcanic ash triggered chemical reactions that continuously reinforced the structure. Instead of weakening with age like most modern concrete, Roman mixtures sometimes became stronger. Scientists estimate that modern concrete structures may last around 50 to 120 years under heavy environmental stress. Certain Roman structures have survived for nearly 2,000 years or more. This has led engineers to investigate Roman formulas as a potential solution for sustainable low-carbon construction. The Appian Way also demonstrates advanced understanding of drainage and soil mechanics. Several parts of the road crossed wetlands and unstable terrain. Rather than placing stones directly onto mud, Roman builders constructed thick load distribution foundations underneath. In some marshy regions, they elevated the roadway using compacted layers that dispersed pressure outward, reducing sinking. This resembles principles used in modern geotechnical engineering. Researchers studying subsurface deformation discovered that some road sections settled gradually and evenly rather than cracking apart. This flexibility may explain why portions of the Appian Way survived earthquakes that destroyed younger buildings nearby. The layered structure distributed seismic energy instead of concentrating stress into rigid fracture points. Similar principles are now used in earthquake-resistant architecture, but the mysteries surrounding the Appian Way extend below the surface. Along the road lies an enormous network of tombs, catacombs, and underground chambers. The catacombs of San Callisto alone contain roughly 20 kilometers of underground passageways spread across multiple levels. These tunnels were excavated with remarkable structural stability despite primitive tools and limited lighting. What puzzles researchers is the ventilation system. Air circulation inside many catacombs remains surprisingly effective even today. Some shafts appear positioned to create natural airflow through pressure differences between chambers. Whether this was intentional engineering or accidental design remains debated. The underground environment also preserved frescoes, inscriptions, and burial chambers for nearly 2,000 years despite humidity and temperature fluctuations. Another strange aspect is the durability of materials used near the catacombs. Roman mortar exposed to moisture underground often remained intact far longer than expected. Modern cement exposed to constant humidity frequently deteriorates through sulfate attack and cracking, yet many Roman underground structures still maintain cohesion. Chemical analysis suggests that volcanic minerals inside the mortar reacted slowly with groundwater, sealing microfractures over time. The sheer scale of the Appian Way raises logistical questions that remain difficult to answer. Building more than 580 kilometers of engineered roadway required staggering amounts of stone, labor, food, tools, and organization. Historians estimate tens of thousands of workers may have participated over several generations. Coordinating transportation, quarry operations, drainage systems, and surveying across such distances would challenge even modern infrastructure projects. The road transformed the Roman military machine. Armies could march up to 30 kilometers per day along stable paved surfaces. Supply wagons moved faster and more reliably than on dirt tracks. Communication across the Republic accelerated dramatically. Some historians argue the Appian Way helped Rome dominate the Mediterranean not only through military strength, but through engineering superiority. Yet perhaps the most unsettling mystery is how advanced Roman infrastructure truly was compared to later civilizations. After the collapse of the Western Roman Empire, Europe lost the ability to maintain many of these roads properly. Some engineering methods vanished for centuries. Medieval roads often became muddy, uneven, and seasonally unusable despite existing in a supposedly more advanced historical era. Sri Lanka's central highlands, near the ancient city of Matala, hide Nalanda Gedige, a stone temple so architecturally strange that historians still cannot fully explain who built it, how its materials survived tropical destruction for over 1,000 years, or why its engineering resembles structures scattered across India, Byzantium, and even the Andes. Nalanda Gedige was rediscovered during British archaeological surveys in the 19th century, but its greatest mystery emerged decades later when engineers realized the structure was not built like traditional Sri Lankan Buddhist temples. After the nearby Boatena Reservoir project threatened the site in the 1970s, The entire monument was dismantled stone by stone and relocated roughly 600 meters away. During that reconstruction, archaeologists discovered highly advanced interlocking masonry systems, unusual mortar compounds, and hidden ventilation channels buried inside the walls. The greatest technological mystery surrounding Nalanda Gedegere is its mortar. Sri Lanka experiences brutal tropical conditions where annual rainfall in central regions can exceed 1,800 millimeters. Humidity regularly stays above 70%, and biological erosion from roots, moss, fungi, and insects destroys most exposed stone structures over centuries. Yet parts of Nalanda Gedigere's bonding material remain remarkably intact after nearly 1,000 years. Modern material scientists studying ancient Asian architecture have compared its durability to Roman pozzolanic concrete, the same technology that allowed Roman harbours to survive underwater for 2 millennia. But unlike Roman concrete, Nalanda Gedigere's formula was never documented in surviving historical texts. Microscopic analysis suggests the mixture may have contained high-temperature lime, finely crushed quartz-rich sand, plant resin compounds, organic ash, and clay minerals with hydraulic properties. The mystery deepens because ordinary lime mortar in tropical climates normally deteriorates rapidly through carbonation and water penetration. Yet some internal joints at Nalanda Gedigere still show unusually strong adhesion and low moisture infiltration. Researchers from South Asian conservation studies have proposed that ancient builders may have accidentally or intentionally created a proto-hydraulic mortar capable of resisting water absorption. Similar theories exist for Roman marine concrete in Italy, Persian Sarouge waterproof mortar, and Maya lime plasters used in humid jungles. But Nalanda Gedigere presents an even stranger puzzle. The mortar appears optimized not only for strength, but also for thermal regulation. Certain wall sections absorb less daytime heat than surrounding reconstructed stone, suggesting the material itself may have helped stabilize internal temperatures. Some engineers believe microscopic air pockets inside the mixture acted as primitive thermal insulation. If true, the builders understood environmental engineering at a level rarely associated with medieval Sri Lanka. Even more mysterious is the disappearance of the technology. Later Sri Lankan structures often use simpler compounds with significantly lower durability, as if the original formula vanished completely from regional knowledge. Nalanda Gedigere looks almost alien compared to nearby Sri Lankan Buddhist architecture. Instead of the rounded stupas common to Sinhala construction, the temple resembles South Indian Dravidian shrines built by the Pallava or Chola civilizations. The roof profile, stone corridors, and decorative geometry resemble temples hundreds of kilometers away across the sea, raising a major historical question. How did such advanced cross-cultural engineering appear deep inside Sri Lanka centuries before modern transportation networks? Some historians believe Nalanda Gedigere may represent a forgotten fusion center between Buddhist Sri Lanka and Hindu South India, while others argue that traveling guilds of engineers carried architectural knowledge across Indian Ocean trade routes. The precision of the stonework creates another layer of mystery. Several granite blocks fit together with extremely narrow tolerances, and during reconstruction studies, archaeologists found joints so tight that thin metal blades struggled to pass between them. Comparable precision appears in Inca polygonal walls at Machu Picchu, Nabatean stone facades at Petra, Byzantine imperial masonry, and certain Khmer temple foundations. Yet Sri Lanka was not historically known for massive precision stone architecture on this scale. No surviving records explain the measurement systems used to achieve this symmetry. Without lasers, steel tools, or industrial machinery, ancient builders somehow maintained alignment across complex load-bearing stone sections. One of the least discussed mysteries involves structural stability. Nalanda Gediger has survived earthquakes, monsoon cycles, invasive vegetation, and centuries of abandonment, and part of this resilience appears linked to hidden interlocking mechanisms inside the masonry itself. Rather than depending entirely on mortar, many stones distribute weight through carefully angled contact surfaces. Engineers studying the reconstruction observed that some blocks function almost like compression locks, redirecting vertical force sideways across the structure. This principle resembles seismic-resistant engineering seen in Inca walls in Peru, ancient Japanese timber joints, Roman arches, and Himalayan stone monasteries. The strange part is that Sri Lanka has relatively limited evidence of such advanced anti-collapse stone systems elsewhere during the same period. Some experts speculate that builders intentionally designed the structure to withstand tropical soil movement and seasonal expansion caused by moisture fluctuations, while others believe the engineering knowledge may have originated from foreign craftsmen connected to Indian Ocean trade. Either way, the structure demonstrates a level of load distribution understanding far beyond what many assume medieval South Asian builders possessed. Even today, visitors notice that the interior remains cooler than the outside air. Sri Lanka's central regions often exceed 30 degrees Celsius, yet the inner chambers of Nalanda Gediger can feel significantly calmer and less humid. Researchers believe this effect comes from a combination of thick thermal mass walls, narrow airflow channels, shaded stone geometry, and hidden ventilation cavities. Some openings disguised within decorative carvings appear positioned to create natural convection currents, allowing hot air to rise upward while cooler air flows through lower passages, producing passive air circulation without mechanical systems. Modern sustainable architects compare this principle to Persian wind catchers, Egyptian desert ventilation shafts, and Roman bathhouse airflow systems. The remarkable part is that the cooling system is almost invisible because the engineering is embedded directly into the aesthetics of the structure itself. This suggests the builders were not merely artists or religious craftsmen. They understood environmental physics in practical ways centuries before modern climate engineering. Many carvings inside Nalanda Gediger display astonishing geometric balance. Curved surfaces remain unusually smooth despite the hardness of the stone. Symmetrical floral patterns repeat with minimal visible deviation, and certain decorative cuts appear polished rather than roughly chiseled. Experimental archaeologists attempting to reproduce similar finishes using replicated medieval tools found the process extremely time-consuming, with comparable smoothness on hard stone requiring thousands of repetitive abrasion cycles. Some theories suggest ancient craftsmen used quartz sand polishing, bow drill rotary cutting, copper alloy shaping tools, and water-assisted abrasion techniques. But no definitive evidence explains how such consistency was maintained across the entire monument. The lack of obvious tool marks has fueled endless speculation. While mainstream archaeology attributes the craftsmanship to highly skilled artisans, others argue the precision hints at lost construction methods no longer fully understood today. Do you think Nalanda Gediger was simply a religious temple, or evidence of a lost exchange of ancient engineering knowledge between civilizations? Share your thoughts in the comments below. On the White Cliffs of southeastern England, overlooking the narrowest point of the English Channel, Dover Castle has guarded Britain for nearly 2,000 years. Only 34 kilometres separate Dover from continental Europe, making this one of the most strategically important military positions in Western history. But beneath its medieval walls lies something far stranger. Evidence that multiple civilizations may have possessed engineering knowledge far beyond what historians once believed. The site was first identified by Roman forces shortly after the invasion of Britain in 43 AD. Archaeological excavations revealed Roman foundations, signal systems, deep wells, military storage chambers, and one of the oldest surviving Roman lighthouses in the world. Yet the more researchers studied Dover Castle, the more impossible its survival began to seem. The fortress stands on unstable chalk cliffs, constantly exposed to salt air, rain, wind erosion, and geological movement. Modern concrete structures near coastlines often deteriorate within decades due to chloride penetration and moisture damage. Yet parts of Dover's Roman masonry have survived almost 20 centuries. Even more mysterious are the underground tunnel systems, shock-resistant defensive walls, hidden water technologies, and optical communication networks that appear centuries ahead of their time. What exactly did the builders of Dover Castle understand about engineering, geology, and military science? And why do some of its technologies resemble concepts used in modern defense systems? Inside the castle complex stands the Roman Pharos, built sometime during the 1st century AD. Originally nearly 24 meters tall, it served as a navigational lighthouse for Roman ships crossing the Channel. Today, it remains one of the best preserved Roman structures in Britain. The mystery is not merely its age. It is the fact that it still exists at all. Coastal structures face some of the harshest environmental conditions on Earth. Salt water accelerates chemical weathering, while freezing temperatures expand microscopic cracks inside stone. Over centuries, these cycles normally destroy ancient masonry, yet large sections of the Pharos remain structurally stable after nearly 2,000 years. Scientific analysis suggests the Romans used a sophisticated lime mortar mixed with crushed ceramic fragments. This mixture created a pozzolanic reaction, a chemical process similar to modern hydraulic cement. When exposed to moisture, the material continued hardening over time rather than weakening. Modern researchers comparing Roman concrete with modern Portland cement discovered something astonishing. Some Roman marine concretes show lower long-term cracking rates than many modern materials. In certain studies, Roman harbour concrete demonstrated exceptional resistance to seawater due to mineral growth within microscopic fractures. At Dover, this ancient chemistry may explain why Roman sections survived while later medieval repairs deteriorated faster. The engineering precision is equally strange. The lighthouse walls gradually taper upward, reducing stress loads while maintaining stability against powerful channel winds. This principle resembles load distribution calculations still used in modern tower construction. Some historians argue the Romans simply relied on experience. Others believe they possessed a practical understanding of material science far more advanced than previously assumed. Beneath Dover Castle lies a massive tunnel system carved deep into chalk bedrock. Some tunnels were expanded during the Napoleonic Wars and World War II, but archaeologists believe portions may follow much older underground routes dating back to medieval or even Roman military activity. The engineering problem is enormous. Chalk is relatively soft and vulnerable to collapse when exposed to moisture or vibration. Modern tunneling projects in chalk formations require extensive reinforcement systems. Yet many sections beneath Dover remained stable for centuries with surprisingly limited structural support. Researchers studying the tunnels noticed something unusual about their geometry. Certain corridors curve slightly instead of following straight lines. At first, historians assumed this was due to primitive excavation methods, but structural engineers later proposed another explanation. Curved tunnels distribute stress waves more effectively than perfectly straight passages. This means the tunnel system may have been intentionally designed to reduce collapse risk from impacts, vibrations, or enemy attacks. Similar concepts appear in modern blast-resistant military bunkers. Ventilation is another unresolved mystery. Deep underground chambers normally suffer from humidity buildup, oxygen depletion, and toxic smoke accumulation. Yet several Dover tunnel sections demonstrate surprisingly effective passive airflow. Temperature differences between upper and lower shafts may have created natural air circulation systems similar to those later used in underground fortresses during the Second World War. Comparisons have even been made to the underground cities of Cappadocia in Turkey, where ancient builders engineered airflow systems advanced enough to support thousands of people below ground. How medieval or Roman engineers understood these geological principles without modern instruments remains unclear. Dover Castle's defensive walls contain another engineering mystery. Many wall segments are not perfectly straight. For centuries, historians believed this resulted from inconsistent medieval construction. But modern military analysis suggests these irregular angles may have been intentional. Straight walls concentrate impact energy when struck by siege weapons. Slightly angled surfaces help disperse force across a larger area, reducing catastrophic collapse. This principle resembles modern ballistic deflection systems used in armoured vehicles. The internal structure of the walls is equally sophisticated. Outer stone layers surround a core filled with rubble, mortar, and smaller stones. This layered design behaves similarly to composite materials, combining rigidity with shock absorption. When trebuchets launch projectiles weighing over 100 kilograms at medieval fortifications, most walls cracked at stress concentration points. Yet parts of Dover's fortifications absorbed repeated impacts without total structural failure. Some engineers compare the concept to earthquake-resistant masonry systems, where controlled flexibility prevents sudden collapse. The fortress also uses elevation strategically. Positioned approximately 110 meters above sea level, Dover Castle dominates both coastline and inland approaches. This height advantage created overlapping defensive sightlines capable of detecting enemy movement far earlier than lower fortresses. Military historians later called Dover the key to England. But the deeper question remains: how did medieval builders intuitively understand structural mechanics centuries before formal engineering science existed? Dover's location allowed direct visual communication across vast distances. Long before telegraphs or radio, this fortress may have operated as part of an advanced optical signalling network stretching across southern Britain. Evidence of beacon platforms and fire warning systems exists throughout the region. Roman and later Saxon defences likely used elevated signal fires to transmit military alerts between coastal positions. But some researchers suspect the system was far more sophisticated than simple fires. Experimental reconstructions showed that beacon chains under clear conditions could relay warnings across hundreds of kilometers within minutes. Variations in flame timing, intensity, or sequence may have functioned as coded messages, essentially an ancient form of optical telegraphy. The concept resembles later semaphore systems developed in 18th century Europe. Yet Dover's signalling traditions may predate them by over 1,000 years. Roman military manuals also describe coordinated communication networks using mirrors, torches, and elevated towers. Combined with Dover's strategic position facing continental Europe, the fortress may have served as an intelligence and surveillance hub far beyond what historians traditionally imagined. If true, Dover Castle was not merely a fortress. It was part of an ancient information network. One of the greatest challenges for any medieval fortress was water. Without reliable water access, even the strongest castle could fall during siege warfare. Yet Dover Castle maintained long-term survivability despite sitting atop highly porous chalk terrain where rainwater drains rapidly underground. Ancient engineers solved this problem through deep wells cut directly into bedrock. Some wells descend more than 100 feet into the chalk aquifer below. Excavating vertically through unstable rock using ancient tools required astonishing precision. A small directional error could miss underground water sources entirely. Modern hydrogeologists believe ancient builders may have identified groundwater through subtle environmental clues. Vegetation patterns, humidity changes, mineral deposits, or seasonal temperature differences in rock fissures. The system also included rainwater collection and storage technologies designed to minimize contamination during siege conditions. This was critically important because disease often killed more defenders than enemy attacks. Compared to many medieval cities suffering from polluted water systems, Dover's infrastructure appears unusually advanced and strategically planned. More than 3,500 meters above sea level in the Peruvian Andes, hidden among clouds, cliffs, and razor-sharp mountain ridges, Rupac appears like the remains of a civilization that should never have existed there. Archaeologists first reached the site through steep mountain trails used for centuries by local shepherds, but what they found made little sense. Massive stone structures stood balanced on unstable slopes in one of the most earthquake-prone regions on Earth. Even stranger, many of the walls appeared older than the Inca Empire itself. The site is believed to have been built by the mysterious Atavillos culture, sometime between the 10th and 15th centuries, yet the engineering techniques found there resemble technologies that should not have existed in such an isolated mountain civilization. The first mystery surrounding Rupac is its earthquake-resistant construction. Peru lies directly along the Pacific Ring of Fire, where the Nazca Plate collides beneath the South American plate at roughly 7 to 9 centimeters per year. This tectonic collision produces some of the strongest earthquakes on the planet. Modern engineers spend billions designing anti-seismic structures in the Andes, yet many walls at Rupac have survived centuries of tremors without steel reinforcement, concrete, or modern foundations. The stone blocks were cut and fitted together with astonishing precision. In some areas, the gaps between stones are so small that even a knife blade cannot fit between them. Similar techniques are famous at Machu Picchu and Sacsayhuaman, but Rupac remains more mysterious because the Atavillos civilization left behind almost no written records explaining how these methods were developed. What fascinates archaeologists most is the geometry of the walls. Many structures lean slightly inward, creating trapezoidal forms that distribute seismic energy more effectively. Modern earthquake engineering uses similar principles in flexible high-rise buildings. During earthquakes, rigid walls crack under stress, but angled structures absorb vibrations and redirect force downward. Studies on Inca masonry have shown that irregular polygonal stones can shift slightly during tremors and then settle back into place without collapsing. Rupac appears to use the same concept, but on steep mountain terrain where construction should have been even more difficult. The next mystery is transportation. Rupac was built in an environment where moving stone should have been nearly impossible. The slopes around the site are narrow, dangerous, and often covered in fog. Some stone blocks weigh several tons, yet the civilization that built Rupac had no known wheeled transport system and no draft animals powerful enough to haul heavy loads uphill. Llamas could carry only about 25 to 30 kilograms each, far too little for megalithic construction. Even today, transporting construction materials to similar elevations requires helicopters or heavy machinery. Researchers believe the Atavillos may have used massive teams of workers with rope systems made from woven plant fibers, but no complete reconstruction has successfully demonstrated how such large stones could have been maneuvered safely across the mountain cliffs. The mystery becomes even deeper when scientists examine the climate engineering of Rupac. Temperatures in the high Andes fluctuate dramatically. Daytime temperatures can become intensely hot under direct sunlight, while nighttime temperatures often drop close to freezing. Yet many rooms inside Rupac appear designed to stabilize internal temperatures naturally. Thick stone walls absorb heat during the day and slowly release it at night, a process known today as thermal mass regulation. Small ventilation openings create controlled airflow that reduces heat buildup while preserving warmth after sunset. Similar environmental engineering appears in Persian yakhchals, Roman hypocaust systems, and Middle Eastern wind towers. But seeing comparable thermal concepts developed independently in isolated Andean mountains raises major questions about the sophistication of pre-Columbian engineering knowledge. One of the strangest structures at Rupak is the group of towering funerary buildings known as chulpas. Some rise nearly 3 stories high and sit dangerously close to cliff edges. Building vertically on unstable mountain terrain without mortar should have been extremely risky. Yet many of these towers remain standing after centuries of earthquakes, rain, and erosion. Geological surveys suggest the builders may have intentionally anchored structures directly onto exposed bedrock rather than softer soil layers. This indicates a practical understanding of slope stability and weight distribution long before modern geotechnical engineering existed. In many ways, Rupak resembles an ancient laboratory where survival and engineering became inseparable. Another unexplained feature is the water system. Rupak sits in a region where maintaining a large population would have required advanced water management. Archaeologists discovered channels, reservoirs, and collection systems designed to trap rainwater and mountain moisture. Some researchers believe the Atavilos may have harvested condensation and fog in a way similar to modern fog-catching technology used today in parts of Chile and Peru. Modern fog collectors can produce several liters of water per square meter each day under the right conditions. If ancient engineers understood even a primitive version of this principle, it would explain how a large mountaintop settlement survived in an environment with limited freshwater access. The site also contains evidence suggesting astronomical alignment. Certain doorways and wall openings appear positioned towards specific solar events, including solstices and seasonal sunrises. Ancient civilizations across the world often align structures with celestial cycles. Chaco Canyon in North America, Nabta Playa in Egypt, and Stonehenge in Britain all demonstrate sophisticated astronomical awareness thousands of years ago. Rupak may represent another example of a civilization integrating astronomy into architecture, religion, and political authority. Some researchers believe the mountaintop location itself was symbolic, placing the settlement physically closer to the sky and the gods worshipped by the Atavilos people. Yet perhaps the greatest mystery is the civilization behind the city. Unlike the Inca, the Atavilos remain poorly understood. Spanish chroniclers mention them only briefly, and much of their culture disappeared following conquest and disease after European arrival in the 16th century. Because of this, Rupak exists almost without historical context. Archaeologists are forced to reconstruct the story entirely from stone, landscape, and fragments of pottery. Burn marks found on parts of the site suggest conflict or ritual destruction before abandonment, but nobody knows whether Rupak fell to warfare, environmental collapse, political instability, or deliberate evacuation. The isolation of Rupak may also explain why the site remained relatively unknown for so long. Thick mountain fog often covers the ruins, making them nearly invisible from below. The city appears almost designed to disappear into the Andes themselves. Unlike Machu Picchu, which became globally famous after Hiram Bingham's 1911 expedition, Rupak remains one of Peru's least studied archaeological sites despite containing engineering techniques that rival far more famous ancient cities. Comparisons with other ancient mountain civilizations only deepen the mystery. The Inca mastered stone fitting on a massive imperial scale. Petra engineered hydraulic systems in desert cliffs. Tibetan monasteries survived harsh Himalayan winters using passive heating techniques. But Rupak combines all of these elements simultaneously: seismic engineering, vertical mountain construction, thermal regulation, water harvesting, and astronomical orientation inside a relatively isolated settlement built by a civilization that history barely remembers. Modern structural engineers who study ancient Andean architecture often admit that some of these techniques remain difficult to replicate even today without advanced surveying tools. Precision stone fitting on uneven mountain terrain requires an extraordinary understanding of geometry, weight transfer, and material behavior. Some walls at Rupak appear so precisely balanced that removing a single stone could destabilize entire sections, suggesting the builders understood structural interdependence at a highly advanced level. What do you think the builders of Rupak really understood about engineering and survival in the Andes? Was this knowledge centuries ahead of its time, or are we still missing a major piece of the story? Share your thoughts in the comments below. Barely standing above the collapsing cliffs of East Sussex, England, Hastings Castle looks less like a surviving fortress and more like the remains of something that should have vanished centuries ago. Built immediately after the Norman invasion of 1066 by William the Conqueror, the castle has endured almost 1,000 years of storms, salt corrosion, ground movement, war damage, and coastal collapse. Entire sections of the cliff beneath it have fallen into the English Channel, yet major portions of the structure still remain attached to the unstable rock above the sea. That alone should not be possible. The site was first identified in written records shortly after the Battle of Hastings, when Norman forces rapidly established military control over southern England. Archaeological excavations carried out throughout the 19th and 20th centuries reveal that Hastings Castle was not a temporary wooden fortification, as many historians originally believed. Beneath the visible ruins, researchers uncovered evidence of an unusually advanced stone foundation system combined with imported Caen limestone from Normandy, layered rubble cores and mortar compositions that behaved differently from standard medieval mixtures. What makes Hastings Castle extraordinary is not simply its age. It is the possibility that Norman engineers were using construction principles far more sophisticated than previously assumed. The first mystery begins with the cliff itself. Modern geological studies show that the Hastings coastline is composed largely of soft sandstone, clay, and unstable sedimentary layers highly vulnerable to erosion. Coastal retreat in some nearby sections has measured several meters per century. In simple terms, the ground under the castle has been slowly moving toward the sea for nearly a millennium. Yet instead of building deep, rigid foundations like many Roman structures, Norman builders appear to have used a semi-flexible load distribution method. Excavations revealed compacted rubble beds beneath sections of the surviving walls, almost functioning like primitive shock absorbers. Rather than resisting every shift in the ground, the structure may have been designed to tolerate gradual movement. That concept resembles modern earthquake engineering more than traditional medieval construction. Engineers studying ancient seismic-resistant structures often compare this idea to the flexible stone layering seen at sites like Machu Picchu or certain Byzantine fortifications, where slight movement prevents catastrophic cracking. Hastings Castle was not built in an earthquake zone, but the same principle may have unintentionally protected it from cliff instability for centuries. The second mystery involves the mortar. Salt water is one of the most destructive forces against stone architecture. Salt crystals penetrate microscopic pores, expand over time, and eventually fracture entire surfaces from within. Most medieval coastal fortifications suffer severe deterioration after only a few centuries of exposure. But portions of Hastings Castle's Norman walls still survive despite nearly constant exposure to sea winds and moisture. Material analysis has shown that some mortar samples contain traces of volcanic ash-like particles, unusually fine aggregates, and mineral reactions associated with weak pozzolanic chemistry. Pozzolanic reactions occur when lime interacts with silicates and moisture, creating compounds capable of strengthening over time. This is the same general principle that made Roman concrete so durable that many Roman harbours still exist after 2,000 years underwater. The comparison is impossible to ignore. Roman marine concrete contained volcanic ash from Pozzuoli in Italy, allowing chemical crystallization that strengthened structures continuously in seawater. Hastings Castle did not use true Roman concrete, but some researchers believe Norman masons may have unknowingly recreated fragments of the same chemistry using local materials and recycled Roman debris from Britain. If correct, the castle may preserve one of medieval Europe's closest accidental approximations of ancient Roman long-life mortar technology. The third mystery lies underground. Beneath the surviving ruins are partially collapsed tunnels, storage chambers, and carved passageways whose full purpose remains uncertain. Some were likely used for food storage or military supplies, but several sections are unusually narrow and positioned in ways that make little defensive sense. More puzzling is their ventilation. Despite being carved into damp coastal rock, parts of these underground spaces maintain surprisingly stable airflow. Researchers suspect the tunnels may have used passive pressure differences between openings at different elevations, creating natural air circulation without mechanical systems. This resembles ventilation principles found in far older underground complexes, such as Derinkuyu Underground City, where entire subterranean cities maintain breathable conditions using vertical airflow shafts. Hastings Castle was nowhere near that scale, yet the engineering logic appears strangely similar. If Norman builders intentionally controlled underground airflow, it would suggest a far deeper understanding of humidity management and food preservation than historians usually attribute to 11th century England. The fourth mystery concerns military communication. The castle occupies one of the most strategically visible points on the Sussex coastline. From its elevated position, observers could monitor shipping routes across large sections of the English Channel. Some historians believe Hastings Castle formed part of an early warning network stretching along southern England. This theory becomes more intriguing when examining line-of-sight calculations between coastal high points. Experimental reconstructions suggest beacon fires placed at Hastings could potentially be seen from multiple defensive positions under favourable conditions. In practice, this would allow rapid long-distance signalling using fire or reflected light, essentially a medieval optical communication system. The Byzantine Empire used beacon chains capable of transmitting messages across hundreds of kilometers in a single night. Ancient China also operated smoke signal defense networks along frontier walls. Hastings Castle may represent a Norman adaptation of the same strategic concept shortly after the conquest of England. If true, the Normans established not merely a fortress, but part of a coordinated surveillance infrastructure remarkably advanced for its time. Then there is the chapel. Among the ruins stands the remains of a stone chapel with acoustic behaviour that still confuses visitors today. Tests conducted in partially preserved sections show that certain positions amplify speech naturally through reflected sound waves. Even quiet voices can travel clearly within the chamber. This effect appears in some Romanesque churches, yet Hastings Castle's chapel is unusually compact for such strong resonance. Acoustic engineers note that curved masonry, thick walls, and narrow interior proportions can focus reflected sound in highly specific ways. Whether intentional or accidental, the result would have dramatically enhanced religious ceremonies, making voices seem deeper and more powerful inside the enclosed stone environment. Ancient civilizations repeatedly exploited similar acoustic phenomena. At Chichen Itza, echoes near the pyramid staircase mimic bird calls. In Greek theatres, stone geometry projected voices across enormous audiences. Hastings Castle may preserve a smaller but equally fascinating example of medieval acoustic engineering intuition. Another mystery involves temperature regulation. Although the castle sits on exposed coastal cliffs battered by cold sea winds, excavations suggest some chambers maintained relatively stable internal temperatures year-round. Thick stone walls combined with partially subterranean layouts likely created a primitive thermal buffer system. This passive temperature stabilization resembles concepts used in Persian yakhchals, Roman hippocaust-adjacent storage systems, and underground monastic chambers across Europe. The principle is simple but effective. Stone absorbs heat slowly and releases it gradually, reducing temperature extremes. For soldiers storing food, weapons, and supplies near the coast, such stability would have been critically important. Do you think Hastings Castle survived because of forgotten engineering knowledge? Or was its survival simply an accident of history? Share your thoughts in the comments below.